details of the discount, the marked price, and the selling price. Then the given discount percentage, the MP/SP ratio, is calculated. For the given 30% discount, the MP/SP ratio is 10:7. Similarly, for the given discount of 10%, 12.5%, and 14.2%, the MP/SP ratios are 10:9, 8:7, 7:6. Buy 3 get 1 free is equivalent to getting a 25% discount on each item. You're essentially buying 4 items for the price of 3. If a buy 4 get 1 free is equivalent to getting a 20% discount on each item, you're essentially buying 5 items for the price of 4. Buy 1 get 1 free is equivalent to getting a 50% discount on each item. 10:9. You're essentially buying 2 items for the price of 1. Buy 3 get 1 free is equivalent to getting a 25% discount on each item. Equivalent. You're essentially buying 4 items for the price of 3. Buy 4 get 1 free is equivalent to getting a 20% discount on each item. 20% discounts are calculated as 2019, 10:9, and 5:4 respectively. When we multiply these ratios together, we get 1,684 as the overall ratio. The difference between the marked price and the selling price is 1,000 minus 684, which is 316 units. The overall discount percentage is computed as 316 divided by 1,000 into 100%, which equals 31.6%. Example 2. MP of an article is Rs 6,400. At what price it will be sold after giving 3 successive discounts of 12.5%, 10%, and 25%. The ratios for 12.5%, 10%, and 25% discounts are calculated as 8:7, 10:9, and 4:3 respectively. When we multiply these ratios together, we obtain 320:189 as the overall ratio. 320 units are equal to 6,400 rupees. For these 320 units multiplied by 20, we earn 6,400 rupees. After multiplying 189 units by 20, the selling price is 3,780 rupees. Model 2. Buy X and get Y free. Example 1. A shopkeeper sells an article for 780 rupees after allowing a discount on 14 2/7%, but he gives 3 articles multiplied by 20 of 13 articles. 6,400 rupees of the after article. Multiplying the ratios for 89 units by 7%, the selling price is 3,780 rupees. As 7:6 and 16:3 respectively. Get Y free. When we multiply these ratios together, we obtain 1,780 after allowing a overall ratio. 14 and 2/7 are equivalent to 7 articles multiplied by 3,780 as 7:6 and 16:3 respectively. When we multiply these ratios shopkeeper after allowing a overall ratio. If he sold the article for 3,000 equivalent to 7 articles multiplied by 7 respectively. When we multiply these ratios together, we obtain 80:63 as the overall ratio. 63 units are equivalent to 315 rupees. For these 63 units multiplied by 5, we earn 315 rupees. After multiplying 80 units by 5, the marked price is 400 rupees. Example 3. A bay marks up his goods by 40% and allows a 20% discount. He gives 1 article free on the purchase of 15 articles. In this way, what is his gain? Percent. The ratios for 20% and 1 article free on the purchase of 15 articles are calculated as 5:4 and 16:5 respectively. By multiplying these ratios, we get the overall ratio of 80:60 or 4:3. The difference in price between the marked price and the selling price is 4 minus 3 equals 1 unit. The overall discount percentage is determined as 1 divided by 4 into 100% equals 25%. Assume that the cost price of the goods is 100 rupees. If a bay marks up his goods by 40%, then the marked price becomes 140 rupees. if allows a 25% discount of 140 rupees. Then the selling price becomes 105 rupees. The profit percent or gain percent is the difference between the selling price and the cost price. Hence, 105 rupees minus 100 rupees is equal to 5 rupees. The discount percentage is 5%. Model 3. Profit after allowing discount. Example 1. Mahesh earns 20% profit after allowing a discount of 20%. If he allowed only a 10% discount, then what will be his profit percent? After allowing a 20% discount, Mahesh earns 20% profit. The ratio between marked price to cost price is 100 plus profit percent to 100 minus discount percent. The ratio becomes 3 to 2. The cost price is 2 and the selling price is 3. For our convenience, we take CP is 200 and MP is 300. If he allows a 10% discount of 300 rupees, which is 30 rupees, then the selling price becomes 270 rupees. The price difference between CP and SP is 70 rupees. The profit percentage is the ratio of profit to cost price multiplied by 100, which is 35%. Example 2. The marked price of an article is 480 rupees. If the shopkeeper allows a discount of 10% and gains 8%, if no discount is allowed, so find his profit percent. The shopkeeper allows a 10% discount and gains 8%. The ratio between marked price to cost price is 100 plus profit percent to 100 minus discount percent. The ratio is now 6 to 5. The cost price is 5 unit and the selling price is 6 unit. If he allowed 0% discount, then the selling price is equal to the cost price, which is 6 unit. The difference between CP and SP is 1 unit. The profit percentage is the ratio between profit and cost price multiplied by 100, which is 20%. Example 3. A merchant fixes the sale price of his goods at 15% above the cost price. He sells his goods at 12% less than the fixed price. His percentage of profit is, let's assume that the cost price of the goods is 100 rupees. If a merchant fixes 15% above the cost price, which is 115 rupees, he sells his goods at 12% lesser than the fixed price. That is, 12% of 115 is 13.8. After subtracting this number from the marked price, the selling price is 101.2 rupees. The difference between the selling price and the cost price is 1.2 rupees. The profit percentage is then 1.2%. Example 4. What is the percentage profit in selling an article at a discount of 20% which was earlier being sold at a 40% profit? Let's assume that the cost price of an article is 100 rupees. Earlier, the article was sold at 140 rupees. Because of 40% profit, it is clear that no discount is allowed earlier. Then the SP and MP are equal, which is 140 rupees. Now, CP equals 100 rupees. MP equals 140 rupees. The discount is 20%. Subtracting 20% of the marked price from 140, we get the selling price of 112 rupees. The profit is 12 rupees. The profit percentage is then 12%. Model 4. True discount. Example 1. If the difference between one discount of 30% and two successive discounts of 20% and 10% is 170, then calculate the marked price of an article.
You think all those puzzle ads
the net discount percentage
but
for
today I finally
two
found the
successive
game.
Discount percentages of
Ebony.
20% and 10% is 28%.
That's
Let's
right, guys.
assume that
The same
the
game
marked
you see
price
in
of
those
an
ads.
article is 100 rupees. The difference between 30% and the net discount percentage of 28% is 2%. The two units are worth 170 rupees. Then the selling price for 100 units becomes 8,500 rupees. Model 5. Difference between percentage profit and percentage discount. Example 1. A merchant observed that he earned a profit of SP of 7 kg sugar after selling 21 kg sugar, and the profit earned on 8 kg sugar is equal to the discount given on 16 kg sugar. Calculate difference between his profit percent and discount percent is, after selling 21 kilos of sugar, the merchant makes an SP profit of 7 kilograms. The profit is equivalent to SP of 7 kilos. Profit is the difference between the selling and cost prices. As a result, 21 into SP minus 21 into CP equals 7 into SP. Rearranging the SP and CP yields an SP-CP ratio of 3:2. For our purposes, we will assume that CP equals 20 rupees and SP equals 30 rupees. As a result, the profit is 10 rupees. The profit percentage is calculated as 10 divided by 20 multiplied by 100, which equals 50%. Now, consider the second half of the question statement. The profit earned on 8 kilograms of sugar equals the discount offered on 16 kilograms. The mathematical formula is as follows. 8P is the same as 16D. The profit to discount ratio is 2:1. If the profit is 2 parts, the discount is 1/2 of the value. If the profit is 10 rupees, the discount is 5 rupees. MP becomes 35 rupees if SP is 30 rupees and the discount is 5 rupees. The discount percentage is calculated by dividing the discount of 5 by the MP of 35 times 100, which is 14.28%. Thus, the difference between profit and discount percentage is 35.72%. Option C is the correct answer. Thank you. Subscribe to this channel and press the bell icon to get regular updates. Speed Maths 12. Boat and stream problems. Basic concepts of boat and stream. Let us say U is the speed of the boat in still water, and V is the speed of the stream. Upstream equals U minus V. Represents the speed of the boat when it is traveling in the opposite direction as the flow of the stream. Downstream equals U plus V. Represents the speed of the boat when it is traveling in the same direction as the flow of the stream. These equations can be useful in calculating the time it takes for a boat to travel a certain distance in either direction, as well as the distance traveled. By taking the average of these two speeds, we can determine the speed of the boat in still water. By taking the difference between these two speeds and dividing it by 2, we can determine the speed of the stream. By multiplying the downstream and upstream speeds and dividing by the speed of the boat in still water, we can determine the average speed of the boat over the entire journey. Model 1. Distance calculation. Example 1. A man can row 7 km per hour in still water. If the river is running at 3 km per hour, it takes 6 hours more upstream than to go downstream for the same distance. How far is the place? The speed of the man, U, is 7 km per hour. The speed of the stream, V, is 3 km per hour. Upstream, the difference in speeds is 4 km per hour. The sum of the speeds downstream is 10 km per hour. Therefore the upstream and downstream speed ratio is 4:10. Speed and time are inversely proportional. As a result, the time required for the upstream and downstream ratio is 10:4. The difference in time between upstream and downstream is 6. According to the second statement in the question, the time difference between upstream and downstream is 6 hours. As a result, the number 6 represents the 6 hours. We will solve this problem using either upstream or downstream values based on this information. Take the downstream value of time 4, which represents 4 hours. In the distance formula, substitute 4 hours and 10 km per hour. As a consequence, the total distance traveled is 40 kilometers. Example 2. A man can row 6 kilometers per hour in still water. If the speed of the current 2 kilometers per hour, it takes 3 hours more in upstream than in downstream for the same distance. The distance is the speed of the man, U, is 6 kilometers per hour. The speed of the current, V, is 2 kilometers per hour. Upstream, the difference in speeds is 4 kilometers per hour. The sum of the speeds downstream is 8 km per hour. Therefore the upstream and downstream speed ratio is 4:8. Speed and time are inversely proportional. As a result, the time required for the upstream and the second statement in the question, speed of the man, the time difference between upstream and downstream is 3. The speed of the current, as a result, is 2. The number 4 represents the 3 hours. Upstream, we will solve this problem using either upstream or downstream values based on this information. Take the downstream value of time 4, which represents 3 hours. In the distance formula, substitute 3 hours and 8 km per hour. As a consequence, the total distance traveled is 24 kilometers. Model 2. Time taken. Example 1. The speed of the motorboat is that of the current of water 36 to 5. The boat goes along with the current. In 5 hours 10 minutes. It will come back in. The speed of the motorboat, U, is 36 km per hour. The speed of the current, V, is 5 km per hour. Upstream, the difference in speeds is 31 km per hour. The sum of the speeds downstream is 41 km per hour. Therefore the upstream and downstream speed ratio is 31 to 41. Speed and time are inversely proportional. As a result, the time required for the upstream and downstream ratio is 41 to 31. According to the second statement in the question, the time taken in downstream is 5 hours 10 minutes or 31 by 6. From the time ratio, the number 31 downstream represents the 31 by 6 hours. Then we need to find the time taken to come back original position. If the number 31 downstream represents the 31 by 6 hours, then the number 41 upstream represents the 41 by 6 hours or 6 hours 50 minutes. Example 2. A speed of a man in still water is 6 km per hour and the speed of the stream is 1.5 km per hour. A man rows to a place at a distance of 22.5 km and comes back to the starting point. Find the total time taken by him. The speed of a man in still water, U, is 6 km per hour. The speed of the stream, V, is 1.5 km per hour. The distance is 22.5. The sum of the speeds downstream is 6 plus 1.5 km per hour. The difference in the speeds upstream is 6 minus 1.5 km per hour. The total time taken by a man is the sum of the time taken to cover the distance in downstream and upstream. Substitute these values in the speed, time distance formula, we get the total time taken by a man is 8 hours. Model 3. Speed of boat, stream. Example 1. A boat running upstream takes 8 hours 48 minutes to cover a certain distance, while it takes 4 hours to cover the same distance running downstream. What is the ratio between the speed of the boat and the speed of the water current? The time taken to cover a certain distance in upstream is 8 hours 48 minutes and downstream is 4 hours. The time ratio between upstream and downstream is 44 by 5 to 4. However, speed is inversely proportional to time. The speed ratio between upstream and downstream is 444 by 5 or 511. By taking the average of these two speeds, we can determine the speed of the boat in still water. By taking the difference between these two speeds and dividing it by 2, we can determine the speed of the stream. The ratio between the speed of the boat and the speed of the water current is 8 to 3. Example 2. A man can row at a speed of 7.5 km per hour in still water. If he takes 4 times as long to row a distance upstream as to row the same distance downstream, then the speed of the stream, kilometer per hour, is. The time ratio between upstream and downstream is 4 to 1. However, speed is inversely proportional to time. The speed ratio between upstream and downstream is 1 to 4. By taking the average of these two speeds, we can determine the speed of a man in still water. By taking the difference between these two speeds and dividing it by 2, we can determine the speed of the stream. The ratio between the speed of the boat and the speed of the water current is 2.5 to 1.5. In the ratio, the 2.5 part is equal to 7.5 km per hour. Then the speed of stream 1.5 parts is equal to 4.5 km per hour. Example 3. A, B, and C are situated at the bank of the river which is flowing at a constant rate. B is at an equal distance with A and C. Rahul takes 10 hours to swim from A to B and B to A also. He takes 4 hours to swim from A to C. What is the ratio of the speed of Rahul in still water and the speed of the stream? B is located in the midst of A and C, at an equal distance from each. Rahul takes 4 hours to travel the distance between A and C. It is obvious that the distance between A and B is 2 hours, and the distance between B and C is 2 hours. Rahul swims from point A to point B in 10 hours. If Rahul swims from A to B in 2 hours, then B to A takes 8 hours. Upstream and downstream have a time ratio of 8 to 2 or 4 to 1. Speed, on the other hand, is inversely related to time. The ratio of upstream to downstream speed is 1 to 4. We can calculate Rahul's speed in still water by taking the average of these two speeds. We may calculate the speed of the stream by taking the difference between these two speeds and dividing it by 2. The ratio of Rahul's speed to the speed of the river stream is 5 to 3. Example 4. A boat running upstream covers a distance of 28 kilometers in 7 hours, while covering the distance downstream it takes 4 hours. What is the speed of the boat in still water? Using the speed, time, distance formula, first, we calculate the upstream speed by dividing distance and time, which is 4 kilometers per hour. Then, calculate the downspeed speed using the same formula, which is 7 kilometers per hour. By taking the average of these two speeds, we can determine the speed of a boat in still water, which is 5.5 km per hour. Example 5. A motorboat can travel at 10 km per hour in still water. It traveled 91 kilometers downstream in a river and then returned, talking altogether 20 hours. Find the rate of flow of the river. The motorboat's speed on still water, U, is 10 km per hour. V is the river's speed. The distance by the boat is 91 kilometers. The total downstream speed is more than V kilometers per hour. Upstream, the difference in speeds is 10 minus V kilometers per hour. The entire time taken by a man, 20 hours, is the sum of the time taken to travel downstream and upstream. By solving V, we obtain the river's flow rate, which is 3 kilometers per hour. Model 4. Meeting point. Example 1. Two boats A and B start towards each other from two places, 150 kilometers apart. Speed of the boat A and B in still water are 16 kilometers per hour and 14 kilometers per hour respectively. If A proceeds downstream and B up the stream, then when they will meet? The speed of boat A on still water is 16 kilometers per hour. The speed of boat B on still water is 14 kilometers per hour. The distance between two boats is 150 kilometers. When both boats are traveling in opposite directions, the relative speed is 16 plus 14 kilometers per hour. In the speed formula, substitute 10
I want to take all stress out of the user experience. Let's have the app ready when I'm back.
Speed Math 11. Train-based problems.
Look,
Basic
we've got
concepts
HV
of train-based
It's a
problems.
hypercloud that can be anywhere
The
we need
speed
to
of an object describes the distance traveled divided by the time taken to cover the distance. Thus,
When you
distance
get your
is the
next big
product of
idea,
speed with time.
say
Hole,
sparkly
tree,
ketchup.
boy,
Grammarly's
and girl
tone
are
suggestions
zero
can help
length.
pitch it with
Object,
confidence.
Platforms,
Hey guys, so
bridges,
in the
and
video
tunnels are examples of long objects.
வந்து கடைசி வரைக்கும் மிஸ்
Unit
பண்ணாம பாருங்க.
converters.
So
To
வாங்க
convert
வீடியோக்குள்ள
kilometers
போலாம்.
per hour into meters per second, simply multiply 5 by 18. The answer we get is the speed in meters per second. To convert meters per second into kilometers per
I'm going to show
hour,
you how to turn.
simply multiply by
We're going to go to the
18
advanced
fifths.
settings.
The
This is going
answer
to be
we
your
get is
first
the
reason
speed in
why you
kilometers
can't
per
comment or
hour.
see any
Model
comments
1.
on
Speed
YouTube
of the
is because your
train.
channel was made.
Example 1. A man sees a train passing over a bridge of length 1 kilometer. The length of the train is half of the length of the bridge. If the train passes the bridge in 2 minutes, then find the speed of the train. According to the given conditions, the total distance that the train must cover to cross the bridge is 1 plus half a kilometer, or 1.5 kilometers. Substitute 1.5 kilometers and 2 minutes into the speed, distance and time formula, then multiply by 60 to convert
बहुत सारे
minutes to
दोस्तों ने मेरे को
hours.
कमेंट
As a
करके ये
result,
पूछा
the train speed
आने के
is
बाद जो है
45
कमेंट करने में
kilometers per
परेशानी हो
hour.
रही है तो जो कमेंट
Model
नहीं हो
2.
पा रहा है तुरंत जो है डिलीट हो जा रहा है
Problems.
इसका भी सॉल्यूशन इस
Example
वीडियो के
1.
माध्यम से
A 300 meters long train crosses a platform in 54 seconds while it crosses a signal pole in 18 seconds. What is the length of the platform? According to the given data, it takes 54 seconds to travel the length of a signal pole and a platform. If the train passes through a signal pole in 18 seconds, then it will cross the platform in 36 seconds. A train 300 meters long crosses a signal pole in 18 seconds and the platform in 36 seconds. Based on this information, we will frame two equations. 18 seconds equals 300 meters. The length of platform X is then 36 seconds. By solving X, we obtain the platform's length of 600 meters.
ठीक है, जैसे दोस्तों यहाँ पर आ जाओगे तो आप पोस्ट, तो आपको लाइव वाले ऑप्शन पे आपको क्लिक कर देना है। लाइव वाले ऑप्शन पे जैसे क्लिक करोगे दोस्तों आपको इस प्रकार से इंटरफेस खुल के आ जाएगा। ठीक है, इसके बारे में बताने, ठीक है, बड़ो वो शो होने लगेंगे और कुछ ऐसा सेटिंग बताऊंगा दोस्तों। अभी रुकिए लाइव चैट, ठीक है,
तो लाइक करना, अपने दोस्तों के साथ शेयर करना। अभी भी अगर कोई मन में सवाल हो तो नीचे कमेंट करके जरूर बताना। मिलते हैं एक नेक्स्ट वीडियो में एक नए टॉपिक के साथ।
350 meter platform length including the 250 meter length of the train. The time required passes the 230 meter platform length including the 250 meter length of the train. Based on this information, we will frame two equations. 600 meters equals 50 seconds. 480 meters
उसका
is 10
सॉल्यूशन
seconds.
अभी नेक्स्ट
By
के ऊपर क्लिक
solving
कीजिए।
X, we obtain 40 seconds to pass a platform. A train crosses a bridge of length
देन यहाँ पे जो
150
है
meters in
इसको
15
ऑन कर दीजिए।
seconds
ठीक
and a
है,
man standing on it
इस
in
तरह
9
से
seconds.
आप इसको
What time
आने
will
से भी
this train
प्रॉब्लम,
take to pass a platform of 450
क्योंकि
meters in
अपडेट से
length?
नए फीचर
According
भी
to
जो
the
आता
given
है तभी
data,
मिलता
it takes 15 seconds to travel the man and a bridge. If the train crosses a man in 9 seconds, then it will cross the bridge in 6 seconds. If a train crosses a 150 meters bridge in 6 seconds, then it will take 18 seconds to cross the 450 meter platform. The answer options are not available in 18 seconds. So, we assume that the man is standing on the platform. The time taken to pass the platform is 18 seconds plus 9 seconds, which equals 27 seconds. Model 3. Relative speed. Example 1. 180 meters long train crosses train B of 120 m in length which is running in the opposite direction in 5 and 5/11 seconds. If the speed of train B is 20% more than that of train A, then find the time taken by both trains to cross each other. When are they running in the same direction? Let's say train A travels at 100 kilometers per hour, while train B travels at 120 kilometers per hour. The ratio of the speeds of trains A and B is 100 to 120, or 5 to 6. When both trains are traveling in opposing directions, the relative speed is 6 plus 5 equals 11 kilometers per hour. When both trains are traveling in the same direction, the relative speed is 6 minus 5 equals 1 kilometer per hour. The opposite and same direction speed ratio is 11 to 1. However, speed is inversely proportional to time. The time ratio becomes 1:11. The 1 represents 60 by 11 seconds. Then we need to compute the time taken by both trains to cross each other. When are they running in the same direction? Then we need to compute the time taken by both trains to cross each other. When are they running in the same direction? As a result, 11 into 60 by 11 equals 60 seconds. Model 4. Train accident. Problems. Example 1. A train after traveling for 50 kilometers met with an accident and then proceeds at 3/4 of its former speed and arrives at its destination 35 minutes late. Had the accident occurred 24 kilometers farther, it would have reached the destination only 25 minutes late. What is the speed of the train? Let A be the starting point and B be the ending point. C and D are the locations of accidents. According to the problem, the ratio of the train's speed after an accident to its original speed is 3 to 4. However, speed is inversely proportional to time. The time taken by the train after the accident to the usual time is then 4 to 3. In this case, the time difference is 1. The difference between 35 minutes and 25 minutes is the actual time required to travel the distance, which is 10 minutes. As a result, 1 denotes 10 minutes. We must first calculate the usual time of 3, which represents 30 minutes. Substitute 24 kilometers and 30 minutes into the speed distance and time formula. The train's original speed was 48 kilometers per hour. Example 2. A train met with an accident 3 hours after starting, which detains it for 1 hour, after which it proceeds at 75% directions. Its original speed is 6
it arrives at the destination
11
km
per hour.
Had
the
when
accident
both trains
taken
are
place
traveling
150
in the same
kilometers,
direction,
the
further
relative
along the
speed is
railway
6
line,
minus
the
5
train would have
equals
arrived
1
only
kilometer
2
per
hours
hour.
late.
The
Find
opposite
the
end.
original
Same
speed of
direction
the train.
speed ratio.
Let
A
it
be the starting point and B be the ending point. C and D are the locations of accidents. According to the problem, the ratio of the train's speed after an accident to its original speed is 3 to 4. However, speed is inversely proportional to time. The time taken by the train after the accident to the usual time is then 4 to 3. In this case, the time difference is 1. The difference between 4 and 2 hours is the actual time required to travel the distance, which is 2 hours. As a result, 1 denotes Speed Maths 10. Speed, distance, time. Basic concepts of speed, distance, and time. The speed of an object describes the distance traveled divided by the time taken to cover the distance. Speed is directly proportional to distance and inversely proportional to time. Average speed. Case 1. When the distance is constant, average speed equals 2xy divided by x plus y, where x and y are the two speeds at which the same distance has been covered. Case 2. When the time taken is constant, average speed equals x plus y divided by 2, where x and y are the two speeds at which we traveled for the same time. Relative speed. When two objects are moving in the same direction, the relative speed between the two objects is the difference between their speeds, that is, x minus y. When two objects are moving in the opposite direction, the relative speed between the two objects is the sum of their speeds, that is, x plus y. The total difference in time for two journeys for given two different speeds for traveling certain distances is del t is equal to d1 by s1 minus d2 by s2. When the total difference in time for two journeys and two different speeds for traveling certain distances is distance d is equal to s1 s2 divided by s2 minus s1 into del t. Model 1. Time taken. Example 1. Running at 4/7 of his usual speed, a man covers a certain distance in 28 minutes. Calculate the time taken by the man to cover the same distance, running at his usual speed. The usual speed to current speed ratio is 7 to 4. However, speed is inversely proportional to time. Then the usual time to current time ratio is 4 to 7. These ratios can be used to solve the problem. According to the problem, a man covers a certain distance in 28 minutes. That is, the current time 7 represents 28 minutes. Then calculate the usual time 4. In this case, 7 multiplied by 4 equals 28. Then, multiplying this multiplication factor 4 by the usual time 4 yields the correct answer of 16 minutes. Example 2. Two runners started running simultaneously from opposite ends of a bridge. But a slower runner takes 5 seconds more than a fast runner to cross the bridge. If the speed of the fast runner is double the slower one, then find the time taken by a slow runner to cross the bridge. According to the problem, the speed of the fast runner is double of the slower one. So, the slower runner's speed to the faster runner's speed ratio is 1 to 2. However, speed is inversely proportional to time. Then the time taken by the slower to faster ratio is 2 to 1. That is, the time difference between the runners is 1 representing 5 seconds. Then, calculate the time taken by slow runner 2 is 10 seconds. Example 3. Walking at the rate of 4 kilometers per hour, a man covers a certain distance in 2 hours and 45 minutes. Running at a speed of 16.5 kilometers per hour, a man will cover the same distance in. Let's start by calculating the distance covered by the man while walking. First, we convert 2 hours and 45 minutes into a fraction. An hour is divided into 60 minutes. By dividing 45 minutes by 60 and then adding 2, we can convert the given time in minutes to hours. Time 2 hours 45 minutes equals 11 by 4. The distance equals speed multiplied by time. The distance equals 4 into 11 by 4. 11 kilometers is the distance. We can now use the same formula to calculate how long it would take a man to run the same distance at a speed of 16.5 kilometers per hour. Time is equal to distance divided by speed, which is 11 kilometers by 16.5 kilometers per hour. In order to convert minutes to hours, multiply the result by 60. As a result, the man would cover the same distance in 40 minutes. Example 4. If a car runs at 45 kilometers per hour, it reaches its destination late by 10 minutes, but if it runs at 60 kilometers per hour, it is late by 4 minutes. What is the correct time for the journey? First, we convert minutes into hours. 10 minutes equals 10 by 60 hours. 4 minutes equals 4 by 60 hours. The difference in time del T is 10 minus 4 by 60. When the total difference in time for two journeys and two different speeds for traveling certain distances is distance of the journey is equal to S1 S2 divided by S2 minus S1 into del T. Substitute these values in the equation, we get a distance of 18 kilometers. According to the question, a car runs at 45 kilometers per hour and covers a distance of 18 kilometers. We can now use the speed, distance, and time formula to calculate time taken to complete the distance of 18 kilometers with 45 kilometers per hour. Time is equal to 18 divided by 45, and this fraction is multiplied by 60 in order to convert time in hours to minutes. So 24 minutes is required to cover the 18 kilometer distance. However, the car reaches 10 minutes late. The difference between 24 minutes and 10 minutes is the actual time taken to cover the distance, which is 14 minutes. Model 2. Distance covered. Example 1. Sachin can cover a distance in 1 hour 24 minutes by covering 2/3 of the distance at 4 km per hour and rest at 5 km per hour. The total distance is, let 3x be the total distance that Sachin needs to cover. Then, he covers 2x the distance at 4 km per hour and 1x the distance at 5 km per hour. The time taken to cover a distance is 1 hour, 24 minutes or 7 by 5 hours. We can frame the equation based on this information using a basic formula. T is equal to distance divided by speed. The total time taken to cover a certain distance is the sum of the time taken. 2x by 4 plus x by 5 equals 7 by 5. Solving an equation for x, we get x is equal to 2. Substitute this x value to compute a total distance of 3x, we get 6 kilometers. Example 2. A man goes to his office at 30 kilometers per hour and reaches 15 minutes late. The next day, he goes at 45 kilometers per hour and reaches 5 minutes earlier. Calculate the distance between home to office. The difference in time del T is 15 minus of minus 5, which is 20 minutes. We convert minutes into hours. 20 minutes equals 1 by 3 hours. When the total difference in time for two journeys and two different speeds for traveling certain distances is distance of the journey is equal to S1 S2 divided by S2 minus S1 into del T. Substitute these values in the equation, we get a distance of 30 kilometers. Example 3. Ram goes to his school at the rate of 15 kilometers per hour and reaches 15 minutes late. The next day, he goes 20 kilometers per hour and reaches 5 minutes before. Calculate the distance between his home to school. The difference in time, del T, is 15 minus 5, which is 20 minutes. We convert minutes into hours. 20 minutes equals 20 by 60 or 1 by 3 hours. When the total difference in time for two journeys and two different speeds for traveling certain distances is distance of the journey is equal to S1 S2 divided by S2 minus S1 into del T. Substitute these values in the equation, we get a distance of 20 kilometers. Model 3. Usual speed concept. Example 1. Due to bad weather conditions, an aircraft reduces its speed by 200 km per hour and reaches 30 minutes late on a flight of 1200 km. Calculate the usual speed of the aircraft. Let us assume that the usual speed of aircraft is s and aircraft reduce its speed by 200 km per hour, which is s minus 200. The difference in time del t is 30 minutes or half an hour. The distance of the journey of 1200 kilometers is equal to the product of the usual speed and the new speed divided by differences in speeds into del t. Substitute the usual speed s and the new speed s minus 200 in the equation. Solving s, we get the speed of 800 kilometers per hour. Example 2. A man covers a certain distance on a scooter and travels 3 kilometers per hour faster. He could have taken 40 minutes less, but if he decreased his speed by 2 kilometers per hour, then he become 40 minutes late. Find the distance. Let us assume that the usual speed of the scooter is s. A man travels 3 kilometers per hour faster than the usual speed, which is s plus 3. A man travels 2 kilometers per hour slower than the usual speed, which is s minus 2. The difference in time del t is 40 minutes, not 80 minutes. We convert minutes into hours. 40 minutes equals 40 by 60 or 2 by 3 hours. Distance of the journey is equal to s1 s2 divided by s2 minus s1 into del t. Substitute s and s plus 3 values in the equation. Similarly, substitute s and s minus 2 values in the equation. In order to find the usual speed of s, equate these two equations and solve for s. We get the speed of 12 kilometers per hour. Substitute the speed of 12 kilometers per hour into the first equation. We get a distance of 40 kilometers. Model 4. Average speed concept. Example 1. Rahul goes to his office at 20 kilometers per hour and reaches at 10 a.m. The next day he goes at 30 kilometers per hour and reaches at 8 a.m., but he wants to reach 9 a.m. What must be his speed? We know that Rahul reaches his office at 10 a.m. on the first day, and at 8 a.m. on the second day. We need to find the speed at which Rahul should travel to reach his office at 9 a.m. We solve this problem in a smart way. The average between 8 a.m. and 10 a.m. is 9 a.m. So, let's use the given concept to find Rahul's average speed during the entire journey from his home to the office. Substituting the values of 20 kilometers per hour and 30 kilometers per hour in the formula for average speed. Hence, Rahul should travel at a speed of 24 kilometers per hour to reach his office at 9 a.m. Example 2. A person travels from A to B at a speed of 2.3 by 4 km per hour and comes back from B to A at a speed of 1 by 3 km per hour. Find his average speed for the whole journey. First, convert mixed fractions into irregular fractions. 2.3 by 4 is 11 by 4. 1 by 3 is 4 by 3. Average speed is equal to 2xy divided by x plus y km per hour. Substituting the values of 11 by 4 km per hour and 4 by 3 km per hour in the formula for average speed, we get 88 by 49 km per hour. Convert kilometers per hour to meters per second using the fraction 5 by 18. The average speed for the whole journey is 0.5 meters per second. Model 5. Relative speed. Example 1. A thief was noticed by a policeman from a distance of 200 meters. The thief starts running and the policeman chases him. The thief and the policeman run at the rate of 10 kilometers per hour and 11 kilometers per hour respectively. The distance between them after 6 minutes will be relative speed of policeman with respect to thief is equal to 11 minus 10 km per hour. Convert kilometer per hour into meter per second by multiplying 5 by 18. Also multiply by 60 so that the time is seconds is converted to minutes. The relative distance covered by policeman is now 6 minutes. In the speed distance and time formula, substitute these values. Distance d is equal to 11 minus 10 into 5 by 18 into 60 into 6. The distance between the policeman and thief after 6 minutes will be 100 meters. Model 6. Meeting point. Example 1. Two trains started from station with 60 km per hour and 75 km per hour at 6:30 a.m. and 7 a.m. respectively. Find the distance from station A to the point where both train will meet. The first train leaves at 6:30 a.m. The first train travels at a speed of 60 km per hour. The first Train covers a distance of 60 kilometers in 1 hour. The first train covers a 30-kilometer distance in half an hour. The time difference between first train and the second train is half an hour. When the second train departs at 7 a.m., the first train has traveled 30-kilometer distance. The relative speed of two trains when travels in same direction is 75 minus 60 kilometers per hour. The time required to travel 30 kilometers is 30 divided by 75 minus 60, which equals 2 hours. The distance from station A to where the trains meet is 75 into 2 equals 150 kilometers. As a result, the trains will meet 150 kilometers away at station A. Example 2. The distance between Mohan and Sohan is 500 meters. They started walking towards each other at the rate of 10 km per hour and 15 km per hour respectively at 7 a.m. Find at what time they will meet and also find the distance from origin of Mohan to the meeting point. When traveling in opposite directions, the relative speed of Mohan and Sohan is 15 plus 10 km per hour. The time required to travel 500 meters is 500 divided by 15 plus 10. It is noticed that the distance is expressed in meters but the speed is expressed kilometers per hour. As a result, multiply 18 by 5 to convert kilometer per hour to meter per second. The time required to travel 500 meters is 72 seconds. The distance from Mohan's origin to the meeting point is 10 into 72 into 5 by 18 equals 200 meters. As a result, Mohan and Sohan will meet at 200 meters. The correct answer is option B. 7 hours 1 minute 12 seconds, and 200 meters. Model 7. Forward, backward problems. Example 1. An insect moves forward by 4 centimeters in 1 second and in next second it moves backward by 2 centimeters. Calculate the time taken by insect to cover distance of 20 centimeters. An insect moves forward 4 centimeters in the first second. An insect moves 2 centimeters backward in the next second. This is the pattern. After 2 seconds, the total distance traveled by an insect, both forward and backward, is 4 centimeters minus 2 centimeters, equaling 2 centimeters. Similarly, the total distance covered by an insect 16 centimeters in both directions is 16 seconds. An insect moves forward 4 centimeters in the next second. 16 plus 4 is 20 centimeters. Distance covers by 16 plus 1 or 17 seconds. Model 8. Cart problems. Example 2. The circumference of the front wheel of a cart is 40 feet long and that of the back wheel is 48 feet long. What is the distance traveled by the cart when the front wheel has done 5 more revolutions than the rear wheel? Speed Maths 9. Ratio and proportion tricks. A ratio is a comparison of two quantities. A ratio can be expressed as a fraction, using a colon. A proportion is an equation that states that two ratios are equal. If two ratios are proportional, it means that they can be written in the same ratio form. Model 1. Basic concept. Example 1. 30% of A equals 50% of B. Find A. B. Percentage and 0 are cancelled on both sides. 3A equals 5B. Then the ratio A by B is equal to 5 by 3. Therefore, the ratio of A to B is 5 to 3. Example 2. 6% of A equals 12% of B. Equals 20% of C. Find A, B, C. We can start by using equality. 6A equals 12B equals 20C. Dividing equality by 2, we get 3A equals 6B equals 10C. We can start by using the given equalities to write three ratios. Taking the LCM of 3, 6, and 10, we get 30. Simplifying by dividing all terms by 30, we get A by 10 equals B by 5 equals C by 3. Therefore, A, B, C equals 10 to 5, 3. Example 3. If P, Q equals 8 to 15 and Q, R equals 3 to 2. Then find P, Q, R. We can start by using the given ratios to find a common ratio for P, Q, and R. P, Q equals 8, 15, and Q, R equals 3 to 2. P, Q, R equals 8 into 3 to 15 into 3 to 15 into 2 is equal to 24, 45, 30. Here, the consequent of the first ratio should be equal to the antecedent of the second ratio. Dividing the ratio by 3, we get the required answer 8, 15, 10. Example 4. If P, Q equals 2 to 3, Q, R equals 4 to 5, and R, S equals 2 to 3, then find P, Q, R, S. We can start by using the given ratios to find a common ratio for P, Q, and R. P, Q equals 2 to 3 and Q, R is equal to 4 to 5. P, Q, R equals 2 into 4 to 4 into 3 to 3 into 5 is equal to 8, 12, 15. Here, the consequent of the first ratio should be equal to the antecedent of the second ratio. R, S equals 2 to 3. P, Q, R, S equals 2 into 8, 2 into 12, 2 into 15, 3 into 15. P, Q, R, S is equal to 16, 24, 30 to 45. Model 2. Combined ratio. Example 1. If P, Q equals 8 to 15 and Q, R equals 5 to 8, and R, S equals 4 to 5, then find P, S. Multiplying the second ratio by 3, so that the consequent of the first ratio should be equal to the antecedent of the second ratio. Then the second ratio Q, R becomes 15, 24. Similarly, multiply the third ratio by 6. So, the consequent of the second ratio should be equal to the antecedent of the third ratio. Then the third ratio R, S becomes 24, 30. Therefore, P, S is equal to 830. Example 2. Of the three numbers, the ratio of the first and second is 8 to 9 and that of the second and third is 3 to 4. If the product of the first and third number is 2400, then the second number is. Let the first and the second number be 8x and 9x respectively, multiplying the second ratio by 3, so that the consequent of the first ratio should be equal to the antecedent of the second ratio. Then the second ratio becomes 9x, 12x. The product of the first and third numbers 8x into 12x is 96x square. This 96x square is equal to 2400. Then x is equal to 5. Therefore, we need to find 9x, which is 45. Model 3. Distribution of amount. Example 1. A profit of Rs 8,000 is to be distributed among A, B, and C in the ratio 5 to 2, 3 respectively. What is the difference between the shares of A and B? The sum of A, B, and C is equal to 10. The difference between A and B is 3. The value 10 is equal to 8,000. Then the value 3 becomes 2,400. Example 2. A sum of money is divided among A, B, C, and D in the ratio 3:5, 8:9. If the share of D is rupees 1872 more than the share of A, then what is the total amount of money of B and C? The difference between D and A is 6. The sum of B and C is 13. The value 6 is equal to 1872. Then the value 13 becomes 4056. Model 4. Percentage change. Example 1. Seats for electronics, mechanical, and civil departments in a college are in the ratio 5:7, 8. There is a proposal to increase these seats by 40%, 50%, and 75% respectively. What will be the ratio of increased seats? Let the initial number of seats for electronics, mechanical, and civil be 50, 70, and 80 seats respectively. 40% of 50 is 20 seats. 50% of 70 is 35 seats. 75% of 80 is 60 seats. Hence, the ratio of increasing percentage will be 20, 35, 60. Then, after the proposed increase, the number of seats will be the sum of these two ratios. After the percentage increase, seat ratio will be 70, 105 to 140. By simplifying we get 2, 3 to 4. Model 5. Including or excluding concepts. Example 1. The total number of students in the school was 660. The ratio between boys and girls was 13:9. After some days, 30 girls joined the school and some boys left the school, and the new ratio between boys and girls becomes 6:5. The number of boys who left the school is, let's start by finding the initial number of boys and girls in the school using the given ratio of 13:9. The total ratio of boys and girls is equal to 13 plus 9, which equals 22. The number of boys equals 13 divided by 22 into 660, which is 390. The difference between the total number of students and the number of boys yields the number of girls. That is 660 minus 390 becomes 270 girls in the school. After 30 girls joined the school, the number of girls becomes 270 plus 30 equals 300. Let's assume that X boys left the school. So, the new number of boys in the school becomes 390 minus X, and the new ratio of boys and girls is 6:5, which means 390 minus X, 300 is equal to 6 divided by 5. 390 minus X divided 300 equals 6 by 5. Simplifying the above equation, we get X is equal to 30. Therefore, the number of boys who left the school is 30. Model 6. Mixture and alligation. Example 1. A mixture contains milk and water in a ratio of 9:11. When 6 liters of milk and 6 liters of water are added to the mixture, the ratio becomes 11:13. Find the initial quantity of milk. The initial ratio of milk and water in the mixture is 9:11. When 6 liters of milk and 6 liters of water are added, the new ratio of milk and water in the mixture is 11:13. The change in water value would be 2 liters. This means the 2 liters in 3 times yields 6 liters of water. To find the initial quantity of milk, the initial value of 9 should be multiplied by 3. The 9 liters in 3 times yields 27 liters of milk. Model 7. Income and expenditure. Example 1. The ratio of monthly incomes of Ram and Shyam is 9:8, and then monthly expenditures are in the ratio of 7:6. If each of them saves rupees 8,000 per month, find the sum of their monthly incomes. The ratio of the monthly incomes of Ram and Shyam is 9:8. The ratio of monthly expenditures is in the ratio of 7:6. The ratio of savings should be the difference between income and expenditure, which is 2:2. The saving 2 value is rupees 8,000 per month. Then the 1 value becomes 4,000. The sum of the monthly income value should be 9 plus 8, which is 17. 1 value is 4,000. Then 17 values should be 17 into 4,000, which is 68,000 rupees. Model 8. Partnership. Example 1. A starts some business with rupees 50,000. After 3 months, B joins him with rupees 70,000. At the end of the year, in what ratio should they share the profit? A invested in the business for 12 months, while B invested for only 9 months since he joined after 3 months. So the profit sharing ratio can be calculated based on the amount of investment and the duration of investment by each person. A's investment is equal to rupees 50,000 into 12, which is 600,000 rupees. B's investment is equal to rupees 70,000 into 9, which is 630,000 rupees. Simplifying this ratio, we get A, B equal to 2021. Hence, A and B should share the profit in the ratio of 2021. Example 2. A, B, and C together start a business. 3 times the investment of A equals 4 times the investment of B, and the capital of B is twice that of C. The ratio of shares of each in the profit. We can start by using the given ratios to find a common ratio for A, B, and C. 3 times the investment of A equals 4 times the investment of B, which is A, B equals 3 to 4. The capital of B is twice that of C, which is B, C equals 2 to 1. A, B, C equals 3 into 2, 2 into 4, 4 into 1, which is equal to 6, 8 to 4. Here, the consequent of the first ratio should be equal to the antecedent of the second ratio. Dividing the ratio by 2, we get the required answer 3 to 4. 2. Model 9. Ages. Example 1. The ratio of ages of Omni and Papu is 4 to 5. After 5 years, their ages will be in ratio 21-25. Find the difference between their ages in years. The ratio of their ages before 5 years is 4 to 5, and after 5 years, it becomes 21-25. The difference between 21 and 25 is 4. Multiplying the ratio of their ages before 5 years by 4, we get 16-20. Therefore, the difference in their ages is 20 minus 16, which is 4. Model 10. Train fare. Example 1. The ratio of first class fare to second class fare is 3 to 1. No of tickets booked of first class to second class is in a ratio 2 to 3. Total fare collected was 1,800 rupees. Find the fare collected from the passengers of second class. The ratio of first class fare to second class fare is 3 to 1. The number of tickets is in the ratio of 2 to 3. The total price of first class to second class is 3 into 2, 1 into 3, which is 6 to 3. The fare collected from the passengers of the second class is equal to the ratio of second class fare and the sum of ratios into the total fare. That is, 3 divided by 9 multiplied by 1800 equals 600 rupees. Alternatively, we can find the fare collected from the passengers of the second class. That is, the total value 6 plus 3 equals 9, which is equal to 1800 rupees. The fare collected from the passengers of the second class ratio is 3. The value 9 is 1800. Then the value 3 becomes 600 rupees. Model 11. Coins. Example 1. A bag contains a certain number of coins rupees 1, 50 paise, and 25 paise in a ratio of 7, 8 to 4. If there are rupees 360 in the bag, then calculate the number of coins of 25 paise. Let's assume that the number of rupees 1 coins, 50 paise coins, and 25 paise coins in the bag are in the ratio of 7, 8 to 4. The total value of the 1 rupee coins in the bag is 1 into 7, which is 7 rupees. Similarly, the total value of the 50 paise coins in the bag is 1 by 2 into 8, which is 4 rupees, and the total value of the 25 paise coins in the bag is 1 by 4 into 4, which is 1 rupee. Therefore, the total value of all the coins in the bag is 7 plus 4 plus 1 equals 12 rupees. However, the given that the total value of all the coins in the bag is rupees 360. Therefore, we can write the following equation. 12x equals 360. Solving for x, we get x is equal to 30. Finally, we can calculate the total number of 25 paise coins by multiplying the number 30 by 4, which is 120. So, the final answer is that there are 120 coins of 25 paise in the bag. Model 12. Diamond. Example 1. The price of a piece of diamond varies according to the square of its weight. When he breaks the diamond into 4 pieces of different weights in the ratio 2 to 3, 4 to 5, he incurs a loss of rupees 28,400. Calculate the price of an original piece of diamond. The given problem states that the price of a diamond varies according to the square of its weight. When the diamond is broken into 4 pieces of weights in the ratio 2 to 3, 4 to 5, the total weight of the diamond remains 14. The price of the 4 pieces can be represented as 2 square is 4, 3 square is 9, 4 square is 16, and 5 square is 25. The price can be represented as 14 square is 196. Now, the total selling price of the 4 pieces can be calculated as the sum of the prices of the individual pieces, which is 4 plus 9 plus 16 plus 25 equals 54. The differences in price result in a loss, which is 196 minus 54 equals 142. The person who breaks the diamond incurs a loss of 142. 142x equals 28,400. Solving for x, we get x is equal to 200. The price of the original diamond is 196 into 200 times, which is 39,200. Model 13. Averages. Example 1. The cricketer whose bowling average is 24.85 runs per wicket, takes 5 wickets for 52 runs and thereby decreases his average by 0.85. The number of wickets taken by him till the last match was. We know that the cricketer's bowling average before the last match was 24.85 runs per wicket. Now, in the last match, the cricketer took 5 wickets for 52 runs. The bowling average of the last match was 52 divided by 5, which equals 10.4 runs per wicket. We also know that his average decreased by 0.85 runs per wicket after the last match, hence the average was 24. Take the cross difference on both sides, we get before the last match 13.6, and in the last match alone 0.85. In order to avoid decimal values, multiply the values by 100. After dividing the ratio by 5, the ratio between before the last match and the last match becomes 272 to 17. Here, the value 17 is represented as 5 wickets. Then, we need to find the total number of matches, which is 272 plus 17 or 289. Then the value 289 is represented as 85. Model 14. Profit or loss. Example 1. A man purchased 1 radio and 1 clock is 2,160 rupees. He sold the radio at 9% profit and clock on 3% loss. In the overall business, he earns a profit of 1% and then calculate the cost price of the clock. The man made a 9% profit on radio. The man lost 3% on the sale of the clock. The overall business should be 1% profit. The difference between 1% and minus 3% is 4%. Similarly, the difference between 9% and 1% is 8%. Simplify the ratio. By dividing the ratio by 2, we get 1 to 2. It implies that the radio has a 1 to 2 ratio to the clock. The sum of 1 and 2 is 3. To calculate the cost price of the clock based on the ratios provided, apply the following formula. The cost price of the clock is equal to the ratio of clock divided by the sum of ratios into the cost price of both items. That is, 2 divided by 3 multiplied by 2,160 equals 1440. Model 15. Simple or compound interest. Example 1. A man borrowed a sum of rupees 30,000, a part of it on simple interest at 12% per annum and the remaining on simple interest at 10% per annum respectively. If at the end of 2 years, he paid in all rupees 36,480 to settle the loan amount, what was the amount borrowed at 12% per annum? A man borrowed a sum of rupees 30,000 rupees. He borrowed money on the simple interest of 12%, which is 12% of 30,000, is 3,600 rupees. He also borrowed money on the simple interest of 10%, which is 10% of 30,000 is 3,000 rupees. A simple interest of 2 years is the difference between 36,480 and 30,000, which is 6,480 rupees. Then simple interest for 1 year is 3,240 rupees. The difference between 3,000 Speed Maths 8. Compound interest. Compound interest refers to interest calculated not only on the principal amount but also on any accumulated interest that has been earned on the principal. Compound interest is commonly used in banking and finance, and it can be found in a variety of financial products, including savings accounts, loans, and investments. Basics of compound interest. The principal, compound interest, and amount are the three main elements of compound interest. The relationship between the principal, compound interest, and amount can be expressed mathematically as the amount is equal to principal plus compound interest. Let us assume that the annual interest rate is 10% per annum. Using effective percentage calculation, we can find the CI for 2 years. The compound interest rate for 10% in 2 years is 21%. The compound interest rate for 10% in 3 years is 33.1%. Similarly, we can find the 20% and 30% interest rates per annum over 2 years and 3 years. For example, given the interest rate is 20%, which equals 1 divided by 5. We know from the compound interest formula the denominator value is principal and the numerator value is compound interest. Then the principal is 5 and the CI is 1. We can calculate the amount that is due at the end of 1 year. Using the formula, A is equal to 5 plus 1, which is 6. We can calculate the compound interest using the formula, CI equals the difference between the amount and the principal. Model 1. Time and rate are given. Let's look at some examples to understand this concept. If the rate of interest equals 12.5% per annum, time equals 3 years, CI equals 1085 rupees. Then calculate the principal and amount in rupees. Given the interest rate is 12.5%, which equals 1 divided by 8. The principal in this example is 8. Add numerator and denominator values to get the amount, which is 9. The principal for 3 years is 8 cube, which equals 512. The amount for 3 years is 9 cube or 729. The compound interest is calculated by subtracting the principal from the amount, which is 217. We must determine how many times compound interest 217 equals 1085. The answer is 5 times. When we multiply 5 by 512, we get the required principal, which is 2560. Similarly, multiplying 5 by 729 gives us the required amount of 3645. Next example, if the rate of interest equals 16.2 by 3% per annum, time equals 3 years, principal equals 6,480 rupees. Then calculate the compound interest and amount in rupees. Given the interest rate is 16.2 by 3%, which equals 1 divided by 6. The principal in this example is 6. Add numerator and denominator values to get amount, which is 7. The principal for 3 years is 6 cube, which equals 216. The amount for 3 years is 7 cube or 343. The compound interest calculated by subtracting principal from amount, which is 127. We must determine how many times the principal 216 equals 6,480. The answer is 30 times. When we multiply 30 by 127, we get the required compound interest, which is 3,810. Similarly, multiplying 30 by 343 gives us the required amount of 10,290. Model 2. Time is given in months or days. If the rate of interest equals 20% per annum, time equals 1 year 73 days, C equals 1550 rupees. Then calculate the principal. Given the interest rate is 20%, which equals 1 divided by 5. The principal in this example is 5. Add numerator and denominator values to get the amount, which is 6. Time 1 year 73 days can be represented as 1 plus 1 by 5. Compound interest is calculated as the sum of the principal value and amount for 73 days, which is 5 plus 6 by 5 or 31 by 5. The principal for 2 years is 5 square, which equals 25. We must determine how many times compound interest 31 by 5 equals 1550. The answer is 250 times. When we multiply 250 by 25, we get the required principal, which is 6,250. Model 3. Interest is compounded yearly, a sum amount of 9,680 rupees in 2 years at 10% per annum compounded annually. Find the principal amount. We can solve this type of question in a smart way using effective percentage calculation. That is, x plus y plus xy by 100. 10 plus 10 plus 10 into 10. Divided by 100. The compound interest rate for 10% in 2 years is 21%. Assume that the principal is 100%. The compound interest is 21%. Then the amount should be 100% plus 21% equals 121%. Based on the information given, we can set up two equations. If 121% equals 9,680, then 100% equals x. We can solve for x by cross-multiplying. Then the amount is 8,000 rupees. Next example. Find the compound interest on 8,000 rupees at 20% per annum for 3 years, compounded annually. To solve this problem, we can use effective percentage calculation. Given, the interest rate is 20% per annum. Using effective percentage formula, the compound interest rate for 20% in 2 years is 44%. For calculating net percent for 3 years, once again we use the effective percentage formula. That is 44 plus 20 plus 44 into 20 divided by 100. Therefore, the compound interest rate for 20% in 3 years is 72.8%. Assume that the principal is 100%. The compound interest is 72.8%. Based on the information given, we can set up two equations. If 100% equals 8,000, then 72.8% equals x. We can solve for x by cross-multiplying. Then the principal is 5,824 rupees. Model 4. Variable rate of compound interest. Find the amount of 8,000 rupees for 2 years compounded annually and the rates being 9% per annum during the first year and 10% per annum during the second year. We can solve this type of question in a smart way using effective percentage calculation. That is, x plus y plus xy by 100. 9 plus 10 plus 9 into 10. Divided by 100. The compound interest rate in 2 years is 19.9%. Assume that the principal is 100%. The compound interest is 19.9%. Then the amount should be 100% plus 19.9% equals 119.9%. Based on the information given, we can set up two equations. If 100% equals 8,000, then 119.9% equals x. We can solve for x by cross-multiplying. Then the amount is 9,592 rupees. An amount of 10,000 rupees is taken as a loan by Rahul at compound interest of 5% per annum for first year, 10% for the second year, and 20% for the third year. What is the total interest to be paid by him after 3 years? To solve this problem, we can use effective percentage calculation. That is 5 plus 10 plus 5 into 10 divided by 100. Then the compound interest rate in 2 years is 15.5%. For calculating net percent for 3 years, once again we use the effective percentage formula. That is 15.5 plus 20 plus 15.5 into 20 divided by 100. Therefore, the compound interest rate in 3 years is 38.6%. Assume that the principal is 100%. The compound interest is 38.6%. Based on the information given, we can set up two equations. If 100% equals 10,000, then 38.6% equals x. We can solve for x by cross-multiplying. Then the principal is 3,860 rupees. Model 5. Interest is compounded half-yearly or quarterly. For example, if rate equals 20% per annum, time equals 1.5 years, and compound interest equals 6,620 rupees. Then calculate the principal and difference between compound interest and SI. Interest is compounded half-yearly. In this case, we must understand that interest is compounded half-yearly, which implies interest is compounded 3 times. As a result, we say the period is 3 years and then perform the calculation. Given, the interest rate is 10%, which equals 1 divided by 10. The principal in this example is 10. Add numerator and denominator values to get the amount, which is 11. The principal for 3 years is 10 cube, which equals 1000. The amount for 3 years is 11 cube or 1331. The compound interest is calculated by subtracting the principal from the amount, which is 331. The difference between compound interest and simple interest is 10 plus 10 plus 11 equals 31. We know that the compound interest value is 331. We must determine how many times compound interest 331 equals 6,620. The answer is 20 times. When we multiply 20 by 1000, we get the required principal, which is 20,000. Similarly, multiplying 20 by 31 gives us the required difference between compound interest and simple interest of 620. Model 6. Compound interest with growing principal. Example 1. A sum of money placed at compound interest doubles itself in 4 years. In how many years will it amount to 8 times? Based on the information given, we can set up an equation. 2 power 1 by 4 is equal to 8 power 1 by t2. Simplifying this equation, we get the required time of 12 years. Second example, a sum of money, amount to 25,000 rupees in 6 years and 27,000 rupees in 7 years. Find the rate of interest. If the time is consecutive years, then we can solve this type of problem using the percentage change formula. That is, percentage change is equal to the final value minus the initial value divided by the initial value into 100. The rate of interest is equal to 27,000 minus 25,000 divided by 25,000 into 100. The rate of interest is 8% per annum. Third example, a sum becomes 4,500 rupees in 2 years and 6,750 rupees in 4 years when compounded annually. Find the principal. In 2 years, a sum becomes 4,500 rupees. In 4 years, a sum becomes 4,500 into 4,500 rupees. In 4 years, a sum becomes 6,750 rupees when compounded annually. The ratio between the amount in 4 years gives us the principal. 4,500 into 4,500 divided by 6,750 is 3,000 rupees is the principal. Fourth example, the difference between compound interest and simple interest on a certain sum of money is 980 rupees. If the rate of interest is 7% per annum, and time equals 2 years, find the sum of money. We can solve this problem using the formula method. The principal is equal to the difference between C and SI into 100 square divided by the rate of interest square. Substituting the difference between C and SI and the rate of interest gives us the required principal, which is 200,000 rupees. Model 7. Difference of compound interest and simple interest. If rate equals 16.2 by 3% per annum, time equals 2 years, the difference between C and SI equals 40 rupees. Then calculate the C, principal, and amount. Given, the interest rate is 16.2 by 3%, which equals 1 divided by 6. The principal, in this example, is 6. Add numerator and denominator values to get the amount, which is 7. The principal for 2 years is 6 square, which equals 36. The amount for 2 years is 7 square or 49. The compound interest is calculated by subtracting the principal from the amount, which is 13, by multiplying the difference between compound interest and simple interest value of 40 rupees into principal, amount, and compound interest values, we get the required answer. When we multiply 40 by 13, we get the required compound interest, which is 520. Similarly, multiplying 40 by 36 gives us the required principal of 1440. Multiplying 40 by 49 gives us the required amount of 1960. Next example, the difference between compound interest and SI for 3 years and 2 years is in the ratio of 19:6. What is the rate of interest? We can solve this problem using the shortcut trick. The interest rate plus 3 equals 19 by 6 into 100. To simplify this equation, the rate of interest should be 16.2 by 3%. Model 8. Comparison of compound interest and simple interest. Find the compound interest at the rate of 7% per annum compounded annually for 2 years on the principal that yields a simple interest of 3,000 rupees for 3 years at 5% per annum. The rate of interest of 5% per annum simple interest for 3 years is 15%, which is equal to 3,000 rupees. The rate of interest of 7% per annum compounded for 2 years is 14.49%, which is equal to X rupees. Based on the information given, we can set up 2 equations. If 15% equals 3,000, then 14.49% equals X. We can solve for X by cross-multiplying. Then the compound interest is 2,898 rupees. Simple interest on a certain sum at a certain rate of interest is 700 rupees for 3 years and 6 months, while compound interest on the same sum at the same rate of interest for 2 years is 425 rupees. Calculate the rate of interest. The simple interest for 3 years and 6 months is 700 rupees. The simple interest for 1 year becomes 200 rupees. The simple interest for 2 years is 400 rupees. The compound interest for 2 years is 425 rupees. The price difference between compound interest and simple interest is 25 rupees. Applying the rate of interest formula, the ratio between the difference between compound interest and simple interest per annum multiplied by 100 is 12.5%. AJ invested a certain sum in scheme A. Speed Maths 7. Simple interest. Simple interest refers to the interest that is calculated on the original principal amount of a loan or investment. It is calculated as a percentage of the principal and is typically expressed as an annual percentage rate. Basics of simple interest. The principal is the initial amount of money that is borrowed or invested. It is the amount on which the interest is calculated. Simple interest is interest calculated only on the principal amount borrowed or invested. It does not take into account any additional interest earned on the interest that has already been accumulated. The amount is the total of the principal and the simple interest earned or paid. It represents the total amount owed or received at the end of the loan or investment period. The relationship between the principal, simple interest, and amount can be expressed mathematically as the amount is equal to principal plus simple interest. Let us assume that the annual interest rate is 10% per annum. Then the simple interest for 2 years at an annual interest rate of 10% would be 20%, and for 3 years it would be 30%. Let's look at one example. Given the interest rate is 20%, which equals 1 divided by 5. We know from the simple interest formula that the principal is 5 and the SI is 1. We can calculate the amount A that is due at the end of 1 year, using the formula, A is equal to 5 plus 1, which is 6. We can calculate the simple interest using the formula, SI equals the difference between the amount and the principal. Model 1. Rate of simple interest. A certain sum of money becomes thrice of itself in 20 years, at a certain rate. Calculate the rate of interest. Assume the principal is 100 rupees. This sum will be multiplied 3 times over the course of 20 years, culminating in 300 rupees. The simple interest is thus 200 rupees. The time period is 20 years. We may determine the interest rate using the formula 200 divided by 20. In this case, the annual interest rate is 10%. Let us now look at the second approach, variable rate of simple interest. First example, Mohan lends out a sum to Ramesh at 6% per annum, a simple interest rate in such a way that the rate of interest increases by 0.5% after the end of every year. Calculate the lent sum. If after 4 years Mohan receives 1080 rupees as interest, assume the principal is 100%. Given that the interest rate is 6%, every year, the interest rate rises by 0.5. Then the interest rates for the following 4 years are 6%, 6.5%, 7%, and 7.5% respectively. The overall interest rate should be 27%, which is equal to 1080 rupees as interest. To solve this problem, we can use the proportionality concept to find the lent sum. Based on the information given, we can set up 2 equations. If 27% equals 1080, then 100% equals x, so we can set up a proportion. 27 divided by 100 equals 1080 divided by x. We can solve for x by cross-multiplying. Then the lent money is 4,000 rupees. Second example, Ria invested a certain sum in a scheme in which the rate of interest is 5% for the first 2 years. It is 7% for the next 3 years, and beyond the 5 years, it is 8%. If after 10 years, Ria received 85,500 rupees as an amount, then what was the invested sum? Assume the principal is 100%. The interest rate of 5% for 2 years is 10%. The interest rate of 7% for 3 years is 21%. The interest rate of 8% for 5 years is 40%. The overall interest rate should be 71%. Then the amount should be 100% plus 71% equals 171%. Based on the information given, we can set up 2 equations. If 171% equals 85,500, then 100% equals x. We can solve for x by cross-multiplying. Then the invested sum is 50,000 rupees. Let us now look at the third model. Time of interest is given. A certain sum of money becomes 4 times itself in 15 years, at a certain rate. Calculate the time in which the same sum will become 10 times itself at the same rate of interest. Suppose the principal is 100 rupees. According to the question, the sum of money grows 4 times in 15 years at a specific rate of interest, resulting in a final value of 400 rupees. Simple interest is equal to the difference between 400 and 100 rupees, which is 300 rupees. Also, the sum of money grows tenfold at the same rate of interest, implying that the final amount after how many years are 1,000 rupees. To find out how many times 300 equals 900, we must first know how many times 300 equals 900. 3 times is the answer. When we multiply 3 by 15, we get the required time in years, which is 45 years. Let us now look at the fourth model. Find the amount when the time and interest are given. The simple interest and the principal at 11.1 by 9% per annum for 7 years can be calculated using percentage to fraction conversion. 11.1 by 9% equals 1 by 9. It is noticed that the numerator value is simple interest per annum while the denominator value is principal. To find the SI for 7 years, multiply SI1 by 7, which is 7. The sum of the principal and SI is 16. The difference between principal and SI results in 2. The value 2 is 3,400. Then the value 16 is 27,200, which is the total amount. Let us now look at the fifth model, SI investments with variable rates. Mahesh invested 3,400 rupees in 2 schemes A and B, in which rate of interest are 10% and 12% per annum respectively. If after 1 year he received 360 rupees as interest from both schemes, then calculate the sum invested in scheme A. We can solve this type of question in a smart way using the proportion technique. According to the question, Mahesh invested 3,400 rupees. He invested 10% in scheme A, which is 10% of 3,400 equals 340. He also invested 12% in scheme B, which is 12% of 3,400 equals 408. The interest in both schemes is 360. The difference between 408 and 360 is 48. Similarly, the difference between 360 and 340 is also 20. It suggests that Scheme A to Scheme B ratio is 12 to 5. Scheme A, Scheme B equals 12 to 5 looks to be a ratio, which signifies that for every 12 units of Scheme A, there are 5 units of Scheme B. Total value 12 plus 5 equals 17 units. To find the sum investment in Scheme A, multiply the ratio of Scheme A unit and the total unit by the principal of Scheme A. The calculation 12 divided by 17 multiplied by 3,400 appears to be an attempt to determine the amount invested in Scheme A using this ratio. Scheme A's investment is thus 2,400 rupees. Second example, A man lends out 9,500 rupees to two persons A and B at the rate of 4% and 6% per annum, respectively. If after 5 years he received 11,500 rupees from both persons, then calculate the sum lent to person A according to the question. A man lends 9,500 rupees. He lends out 4% from person A, which is 4% of 9,500 equals 380. He also lends out 6% from person B, which is 6% of 9,500 equals 570. The difference between the amount of 11,500 rupees and the principal of 9,500 rupees yields simple interest of 5 years, which is 2,000 rupees. The simple interest per year from both persons is 400 per annum. The difference between 570 and 400 is 170. Similarly, the difference between 400 and 380 is also 20. It suggests that Scheme A to Scheme B ratio is 17 to 2. Person A, person B equals 17 to 2 looks to be a ratio, which signifies that for every 17 units of person A, there are 2 units of person B. Total value 17 plus 2 equals 19 units. To find the sum lent in person A, multiply the ratio of person A unit and the total unit by the principal of person A. The calculation 17 divided by 19 multiplied by 9,500 appears to be an attempt to determine the sum amount in person A using this ratio. Scheme A's sum lent is thus 8,500 rupees. Let us now look at the sixth model, SI investments with variable rates or time. 10,400 rupees is invested in 2 parts in such a way that the SI from the first part at 10% per annum for 5 years is equal to the SI on the second part at 8% per annum for 10 years. Find the sum invested at 10%. 10% per annum for 5 years is 50%. 8% for 10 years is 80%. SI of 50% of the first part of the principal is equal to SI of 80% of the second part of the principal. P1 into 50% equals P2 into 80%. Therefore the ratio P1 by P2 equals 8 by 5. The total value of 8 plus 5 is 13. How many times does this 13 value equal 10,400? 800 times. The sum invested at 10% is the first part, which is P1. The initial investment P1 is 8. This first part investment should be 8 times 800 rupees, which is 6,400 rupees. Second example, 12,600 rupees is invested in 3 parts in such a way that the SI on the first part at 2% per annum for 3 years is equal to the SI on the second part at 3% per annum for 4 years is equal to the SI on the third part at 4% per annum for 5 years are equal. Find SI on each part. SI of 6% of the first part of the principal is equal to SI of 12% of the second part of the principal, and 20% of the third part of the principal. P1 into 6% equals P2 into 12% equals P3 into 20%. The ratio approach can be used to solve this problem. Simplifying, we get 3P1 equals 6P2, which equals 10P3. Divide the equation by 30 to get proportional values. As a result, the 3 investments have a 10:5 to 3 ratio. The total value of 10 plus 5 plus 3 equals 18 units. These 18 units are worth of 12,600 rupees. The first part of the investment of 10 units is 7,000 rupees per annum. With 7,000 rupees, we must calculate simple interest over 3 years at a rate of 2%. 7,000 multiplied by 3. And 2% equals 420 rupees in simple interest. Third example, Ganesh invested an equal amount of money in 2 different firms which give 15% per annum simple interest for 3.5 years and 5 years respectively. If the difference between their investments is 225 rupees, the amount invested by Ganesh is, the difference in investment is equal to the product of the time difference of 1.5 and the rate of interest of 15%, which is 22.5%. The difference in the investment of 22.5% is 225 rupees. 1% is 10 rupees. Ganesh then invests 100% of his money, which is 1,000 rupees. Fourth example, the simple interest on 4,000 rupees in 3 years at X% per annum equals the simple interest on 5,000 rupees at 12% per annum in 2 years. What is the value of X? 4,000 into 3 into X% is equal to 5,000 into 2 into 12%. When we simplify the equation, we obtain X, which equals 10%. Thank you. Subscribe to this channel and press the bell icon to get regular updates from our channel. Speed Maths 6. Profit and loss tricks. Profit and loss is the focus of today's discussion. Basic formulas. Remember that profit is the increase in price, whereas loss is the decrease in price. The cost price of an item is the price at which it is purchased, whereas the selling price is the price at which it is sold. The difference between the selling and cost prices represents either a profit or a loss for the seller and is calculated as follows. Profit is calculated as the selling price minus the cost price. The profit percentage is equal to the profit divided by cost price into 100. The loss is equal to the cost price minus the selling price. The loss percentage is equal to the loss divided by cost price into 100. The cost price is always considered as the base or 100% when calculating profit or loss. The discount is the difference between the market price and the selling price of a product. It represents the amount by which the market price is reduced to arrive at the selling price. The discount is equal to the difference between the market price and the selling price. Using the following formula, the discount may alternatively be represented as a percentage of the market price. The discount percentage is equal to the discount divided by the marked price multiplied by 100. Given the cost price of 800, the market price is 1000, and the selling price is 900. The discount is calculated as follows. Discount equals marked price minus selling price, which equals 1000 minus 900 equals 100. The discount percentage is equal to the discount divided by the marked price, which is 10%. Profit is computed as follows. Profit equals selling price minus cost price, which is 900 minus 800 equals 100. Profit may also be expressed as a percentage of the cost price as follows. Profit percentage equals profit divided by cost price multiplied by 100, which is 100 divided by 800 multiplied by 100 equals 12.5%. Let's look at one example. The discount percentage is 15%, which equals 3 divided by 20. We know from the discount formula that the marked price is 20 rupees and the discount is 3 rupees. Use the discount formula to get the selling price. The marked price minus the discount equals the selling price. 20 minus 3 equals 17. It should be noted that the equation is a mathematical expression that calculates the marked price to cost price ratio, where the marked price is 100 plus the profit percentage and the cost price is 100 minus the discount percentage. This expression shows that the ratio of marked price to cost price is equal to the ratio of 100 plus profit percent to 100 minus discount percent. The first model of profit and loss calculation is the profit percentage. Let's look at the first example to understand the basic concept of the profit percentage. A person buys a watch for rupees 200 and sells it for rupees 225. Find his gain percent. Assume the cost price is 100%, which is rupees 200. The selling price of the watch is rupees 225. Gain is calculated as selling price minus cost price. Thus 225 minus 200 equals 25. To get the gain percentage, we must construct two equations, where 100% is 200 rupees. X percent is 25 rupees. By cross-multiplying the terms, we can obtain the profit percentage. Otherwise, divide both sides of the first equation by 8 to get X percent, which is equal to 12.5. Second example. By selling a cell phone for rupees 2,400, a shopkeeper makes a profit of 25%. Then his profit percentage, if he had sold it for 2040, is. From the information given, we know that the shopkeeper made a 25% profit on the sale of the cell phone for 2,400 rupees. Assume the cost price is 100%. The selling price percentage is then calculated as 100 plus 25 equals 125%, or 2,400 rupees. To get the new SP percentage, we must first construct two equations, where 125% is 2,400 rupees. X% is 2040 rupees. By cross-multiplying the terms, we can obtain the X percentage, which is 106.25%. Subtract 100% from 106.25% to obtain profit percent, which is 6.25%. Here is an example to help you understand the basic concept of profit and loss. Samanth bought a microwave oven and paid 10% less than the original price. He sold it with 30% profit on the price he had paid. What percentage of profit did Samanth earn on the original price? To solve this problem, first, we understand that Samanth bought a microwave oven by 10% less than the original price, which is minus 10%. He sold by 30%, which means plus 30%. According to the effective percentage formula, the net percentage between two percentages is minus 10 plus 30 plus minus 10 into 30 divided by 100. In this case, the sum of minus 10 and plus 30 and a fraction of minus 300 divided by 100, which is 17%. Next example. A shopkeeper observed that after selling 33 articles he earns a profit from the selling price of 11 articles. Calculate his profit percent. We know that the profit earned from the sale of an item is equal to the difference between the selling price and the cost price. According to the second equation, the cost price of an item may be calculated by subtracting the profit from its selling price. Based on the given data, the selling price of 33 articles would be 33 into the selling price and its cost price would be 33 into the cost price. The shopkeeper earned a profit by selling 11 articles would be 11 into the selling price. When these numbers are substituted into the calculation, we obtain 33 SP minus 11 SP equals 33 CP. Simplify the equation. To get SP divided by CP equals 3 divided by 2. Here, the cost price is 2, the selling price is 3, and the profit is 1. According to the profit percentage formula, percentage profit equals profit divided by cost price, which is 1 divided by 2 or 50%. Let us now look at the second approach, loss percentage, for resolving profit and loss problems. Here is an example to help you understand the basic concept of loss percentage. A person buys a book for rupees 500 and sells it for rupees 300. What will be his loss percent? Assume the cost price is 100%, which is rupees 500. The selling price of the book is rupees 300. Loss is calculated as selling price minus cost price. Thus 300 minus 500 equals 200. To get the loss percentage, we must construct two equations, where 100% is 500 rupees. X% is 25 rupees. By cross-multiplying the terms, we can obtain the loss percentage. Otherwise, we first calculate 10%, which is 50, then multiply by 4 to get X%, which is equal to 40%. Second example. A fair price. Shopkeeper takes 10% profit on his goods. He lost 20% goods during the theft. His loss percent is. To solve this problem, first, we must first understand that the shopkeeper made a profit of 10%, which is plus 10%. During the theft, shopkeeper lost 20%, which means minus 20%. According to the effective percentage formula, the net percentage between 2 percentages is plus 10 minus 20 plus 10 into minus 20 divided by 100. So, we get minus 12%, which is a 12% loss. Let's look at another example. To better comprehend this loss percent concept, Rahim incurs a loss of selling of 6 hens after selling 144 hens. Calculate his loss percent. We know that the loss from the sale of an item is equal to the difference between the cost price and the selling price. Based on the given data, the selling price of 144 hens would be 144 into the selling price, and its cost price would be 144 into the cost price. The shopkeeper incurs a loss of selling 144 hens would be 6 into the selling price. When these numbers are substituted into the calculation, we obtain 6 into SP equals 144 CP minus 144 SP. Simplify the equation to get SP divided by CP equals 144 divided by 150. Here, the cost price is 150, the selling price is 144, and the loss is 6. According to the loss percentage formula, percentage loss equals loss divided by cost price, which is 6 divided by 150 or 4%. The third model is profit or loss percentage. Let's look at the first example to understand the basic concept of the profit or loss percentage. A gold ring is sold for rupees 16,000 at a loss of 20%. Find the cost price of a gold ring. The selling price of the gold ring is rupees 16,000. Assume the cost price is 100%. The loss percentage is 20%. Then, the selling price is 80%. To calculate the cost price, we must create two equations, where 100% is X, and 80% is 16,000 rupees. Divide both sides of the second equation by 8 to obtain 10%, which is 2,000. Then, 100% equals 20,000. Second example, the owner of the cell phone charges his customer 28% more than the cost price. If the customer paid rupees 8,960 for the cell phone, what was the cost price of the cell phone? Let us assume the cost price is 100%. The profit percentage is 28%. Then, the percentage of the selling price is 128%, which is equal to 8,960 rupees. To calculate the cost price, we must create two equations, where 100% is X, and 128% is 8,960 rupees. Divide both sides of the second equation by 128 to obtain 1%, which is 70. Then, 100% equals 7,000. Let's look at another example. To understand this concept, by selling an article for 720 rupees, a man loses 10%. At what price should he sell it to gain 5%? Let us assume the cost price is 100%. The loss percentage is 10%. Then, the percentage of the selling price is 90%, which is equal to 720 rupees. To calculate the selling price to get a gain of 5%, we must create two equations, where 90% is 720 rupees, and 105% is X. Divide both sides of the first equation by 9 to obtain 10%, which is 80. Then, 100% equals 800, and 5% is 40. The sum of these values is 840 rupees, which is the selling price of the article to gain of 5%. Fourth example, if the cost price of 350 articles is equal to the selling price of 300 articles, then calculate the profit, loss percent in this kind of business. From the information given, 350 times CP is equal to 300 times SP. When rearranging the terms, we get the ratio of CP to SP. CP divided by SP is equal to 300 by 350. The fraction is 6 by 7. It is noted that the CP is 6, and the SP is 7. The profit is equal to the difference between SP and CP, which is 1. We may determine the profit percentage using the formula, which is 1/6. When we convert the fraction into a percentage, we obtain 16.66%. Let us now look at the fourth model for determining total profit or loss. First example. A man purchased one television and one air condition in rupees 51,000. He sold the TV at 10% profit and air condition on 7% loss. Calculate CP of television if in overall business neither he gets profit nor loss. The overall business should not make a profit or a loss, which is 0%. The man made a 10% profit on the television. The man lost 7% on the sale of the air conditioner. The difference between 10% and 0% is 10. Similarly, the difference between 0% and 7% is 7. It implies that the television has a 7:10 ratio to the air conditioner. The sum of 7 and 10 is 17. 2. Calculate the cost price of the television based on the ratios provided. Apply the following formula. The cost price of the television is equal to the ratio of television divided by the sum of ratios into the cost price of both items. That is, 7 divided by 17 multiplied by 5,100 equals 2,100. Second example. A shopkeeper sells one transistor for rupees 840 at a gain of 20% and another for rupees 960 at a loss of 4%. His total gain or loss percent is, let's assume the cost price of the transistor is 100%. The first transistor was sold by the shopkeeper for a 20% profit. As a result, the selling price is 120%, or 840 rupees. Then we must compute the cost price for 100%. The cost price of a single transistor at 100% is 700 rupees. The shopkeeper made a 4% loss on another transistor. As a result, the selling price is 96%, or 960 rupees. The cost price of 100% of another piece is then 1,000. In this scenario, the cost of both transistors is 1,700 rupees, whereas the selling price is 1,800 rupees. Profit is the difference between the selling price and the cost price, which is 100. Then profit percentage is profit divided by cost price into 100. The profit percentage is then calculated by dividing the profit by the cost price into 100. In that instance, 100 divided by 1,700 yields 515 by 17%. Model 5. Discounts. A discount is a reduction in the price of a product or service. It can be expressed as a percentage of the original price or as a specific amount. A discount is usually offered to promote sales or attract customers. Let's look at some examples to understand the discount concepts in profit and loss. A book is marked 80% above the cost price and sold at a 40% discount, if the difference between the discount given and the profit earned is rupees 460.8. Then find the MRP of book. Let's assume the cost price of the book is 100%. A book is marked at 80% above the cost price, which means the marked price will be 180%. The book was sold at a 40% discount, which implies 40% of the 180 is 72%. Then, subtracting 72 from 180 gives 108%, which is the percentage of the selling price of the book. Profit is defined as the difference between the selling price and the cost price, which is 108% minus 100% equals 8%. According to the question, the difference between the discount given and the profit earned is 72 minus 8%, or 460.8. Then we must determine the MRP of the book, which is 180%. Solving these two equations provides 1296 rupees, which is the MRP of the book. Let's look at the second example to understand the discount concepts. A shopkeeper fixes the marked price of an item 35% above its cost price. The percentage of discount allowed to gain 8%. is, let's assume the cost price of the item is rupees 100. An item is marked at 35% above the cost price, which means the marked price will be 135 rupees. To calculate the selling price, the gain of 8% added with cost price results 108. Then, subtracting 72 from 180 gives 108%, which is the percentage of the selling price of the book. The difference between the marked price and the selling price is known as the discount, which is 135% minus 108%, equals 27. Divide the discount by the cost price and multiply by 100 to get the discount percentage. The discount percentage is then calculated by dividing the discount by the cost price into 100. In such case, 27 divided by 135 equals the fraction 1 divided by 5 into 100. When we convert the fraction to percentages, we get a discount percentage of 20%. Here is an example to help you understand the concept of discounts. The cost price of an article was 800, and it is sold at a discount of 10% and at a profit of 12.5%. What is the marked price? To determine the marked price, we must first calculate the profit and then the discount. The cost price of the article is rupees 800. The profit percentage is 12.5%. As a result, the profit will be 12.5% of 800, or 100 rupees. The selling price of the article is the sum of 100 and 800, which is 900. To calculate the marked price from the selling price with a 10% discount, divide 900 by 0.9, which equals 1000 rupees. Next example. A merchant gained 20% after giving a discount of 10%. If the shopkeeper would not allow any kind of discount, then what will be his profit percent? The ratio of marked price to cost price is equal to the ratio of 100 plus profit percent to 100 minus discount percent. By substituting 20% gain and 10% discount in the equation, the fraction becomes 120 divided by 90, or 4 by 3. According to the information in the question, the shopkeeper would not allow any kind of discount, hence discount is 0. As a result, marked price becomes selling price. Then the ratio, SP by CP is 4 by 3. In this case, SP is 4. CP is 3. Profit is 4 minus 3 equals 1. Profit percentage is calculated by dividing profit by cost price, which is 1 by 3 or 33.33%. Let's look at another example. A shopkeeper marked up the price of an article by 40%. He gained a profit of rupees 304 on selling the article if he gave a discount of 15%. Find the selling price of an article. The cost price is 100. A shopkeeper marked up the price of an article by 40%. Then the marked price is 140. When we divide by 20, we get the cost price is 5 and the marked price is 7. We know that the discount percentage is 15%, which is 15 divided by 100, or 3 by 20. In this case, the discount is 3 and the marked price is 20 rupees. The selling price may be determined by taking the marked price minus the discount, which is 20 minus 3, or 17. CP, MP, SP equals 100, 140 to 119. This indicates that for every 100 units of cost price, there are 140 units of marked price, and 119 units of the selling price. The cost price is 100 and the selling price is 119%, resulting in a 19% profit. Profit of 19% is 304. Then we must calculate the 119% selling price. First, find 1%, which equals 16. Then 119% is 119 into 16 is 1904. Let's look at another example to better comprehend the discount concepts. The difference between a discount of 35% and two successive discounts of 20% on a certain bill was 22 rupees. Find the amount of the bill. To solve this problem, we must determine the effective percentage of two successive discounts of 20%. According to the effective percentage formula, the net percentage between two percentages is plus 20 plus 20 plus 20 into 20 divided by 100. As a result, we obtain a net discount of 36%. The difference between a discount of 35% and 36% is 1%. In this case, the 1% is 22, then the 100% is the amount of the bill, which is 2,200 rupees. Model 6. Dishonest shopkeeper. Let's look at some examples to understand this concept. A dishonest shopkeeper professes to sell pulses at the cost price, but he uses a false weight of 960 grams for a kilogram. Find his gain. SP equals 1000 grams. However, a dishonest shopkeeper uses a false weight of 960 grams for 1 kilogram. In this case, CP equals 960 grams. Then, the gain is equal to 40 grams. We may determine the percentage of profit using the profit percentage formula, which is 40 by 960 into 100. The fraction becomes 1 divided by 24% or 41 by 6%. Second example. A shopkeeper sells products at 10% loss on cost price but uses 2 grams instead 4 grams. What is his total profit percentage? Let us assume that CP is 1000 grams. A shopkeeper sells products at 10% loss on cost price. In this case, SP equals 900 grams. However, a shopkeeper uses 2 grams instead 4 grams, which means a 50% reduction in weight. So, the CP becomes 500 grams. Then, the gain is equal to 400 grams. We may determine the percentage of profit using the profit percentage formula, which is 400 by 500 into 100. The fraction becomes 4 divided by 5% or 80%. Let's look at the third example to better comprehend this profit or loss with dishonest shopkeeper concept. Mahesh marks up his goods by 40% and gives a discount of 10%. Apart from this, he uses a faulty balance also, which reads 1000 grams for 800 grams. What is his net profit percentage? Let us assume that CP is 1000. Mahesh marks up his goods by 40%, which is 1000 plus 40% of 1000 grams. 1000 plus 400. In this case, marked price equals 1400. Mahesh gives a discount of 10%, which is 1400 grams minus 10% of 1400 grams. 1400 minus 140 grams is 1260. The selling price is 1260. However, a shopkeeper reads 1000 grams for 800 grams. Then the new CP is 800. Then, the profit is equal to 460. We may determine the percentage of profit using the profit percentage formula, which is 460 by 800 into 100. The fraction becomes 57.5%. Fourth example. A merchant gained 14.2 by 7% due to the use of faulty weight. If the customer purchased a 2 kilogram item, then how much he actually got? The given profit percentage is 14.2 by 7%. We have discussed this in Speed Maths 3. The mixed fraction 14.2 by 7 equals 1 divided by 7. In this case, from the profit percentage formula, the profit is equal to 1. The cost price is 7. The selling price is equal to the sum of these two values, which is 8. In order to calculate the actual profit of 7 parts, we must first determine the profit of 1 part selling 2 kilograms. 2 kilograms divided by 8 equals 250 grams or 1 part. Then multiply this value by 7 to obtain the actual profit, which is 1750 grams. The seventh model of profit and loss is the more loss or less loss concept. Let's look at some examples to understand this concept. First example, the profit earned by selling an article for 730 rupees is double the loss incurred when the same article is sold for 250 rupees. At what price should the article be sold to make a 20% profit? According to the data provided in the question, the profit earned by selling the article doubled the loss incurred. In this case, profit is 1. The loss is 2. The sum of these values is equal to the difference between selling prices. The value 3 is 480. Then, the value 1 is 160. The cost price of 100% is the sum of the selling prices of 250 and 160. In order to find the selling price of the article with 20% profit,
मेरी दवाइयाँ काफी महंगे होते थे, फिर मैंने ट्रूमेट्स ट्राई किया।
ये अब काफी आसान है। ट्रूमेट्स पे अपनी दवाइयों के नाम सर्च किए।
एक कप प्लेट हो सकते हैं, बहुत बढ़िया। पहला बिल्कुल ट्रू है। आगे बढ़ते हैं। नो क्लास इज टीचर। नो क्लास इज टीचर। ऑफ कोर्स यहाँ पे टीचर किसके अंदर है भाई? तो प्रिंसिपल के अंदर है। क्लास और प्रिंसिपल में प्रतिबंध, दैट मींस इसमें प्रतिबंध है। पहला बिल्कुल ट्रू है। सम प्रिंसिपल्स आर नॉट स्टूडेंट। बोला कुछ प्रिंसिपल ऐसे हैं जो स्टूडेंट नहीं है। हमने कहा हाँ भाई टीचर स्टूडेंट नहीं है, तो प्रिंसिपल का कुछ पार्ट ही तो है टीचर। दैट मींस ये भी क्या है? ट्रू है। दैट मींस बोथ फॉलोज अगेन। तो 5 में से 4 सवाल का उत्तर ऑप्शन नंबर ई। और इस तरह के सवाल, जब इस तरह का सिचुएशन जब एग्जामिनेशन में क्रिएट होता है तो बच्चे परेशान हो जाते हैं, सर ऐसा कैसे हो गया? तो ऐसा होता है। और एक सवाल का आंसर डी है, मतलब कि एक सवाल का आंसर डी, बाकी 4 सवाल का आंसर क्या है? ई है। और ये आई थिंक सबका सीक्वेंस रहा होगा ऐसा, सबने इतना 5 बाकी 4 सवाल का आंसर क्या है? ई है। ठीक है।
Speed Maths 5. Average Tricks. The topic that we are looking at today is averages. The average, or mean, of a set of observations is calculated by adding all the observations together and then dividing that sum by the total number of observations. The first model of average calculation is consecutive numbers. Consecutive numbers are numbers that follow each other in order without gaps. For example, 1, 2, 3, 4, 5 are consecutive numbers. Let's look at some examples to understand the average of consecutive numbers. Find the average of given numbers. To find the average of the set of numbers 96, 97, 98, 99, 100, you need to add all the numbers together and then divide that sum by the total number of numbers. But there is a really interesting math trick behind it. For a set of consecutive numbers, the middle number is always the average, also known as the mean of the set. So, you don't waste your time finding the average formula and substituting the values in a second. As you see the question, just write the middle number as the answer. Here, the middle number of the given even number is 98, which is the average of given consecutive numbers. It's important to note that this applies only to consecutive numbers, and not to any set of numbers. Now, let us find the average of the given consecutive numbers 101, 102, 103, 104. Since the set of numbers you provided has 4 numbers, which is even, there are 2 middle numbers, which are 102 and 103. The average of these 2 numbers is 102.5. So, the middle number of the set of consecutive number is 102.5. Similarly, let us find the average of the given consecutive odd numbers 27, 29, 31, 33. By seeing this, it is always known that the middle number is the average value. Here, the middle number is 30, which is the average of given odd numbers. The middle value among given consecutive even numbers 52, 54, 56, 58 is 55, which is the average value. Let's look at some more examples to better comprehend this average concept. A, B, C, and D are 4 consecutive odd numbers and their average is 42. Find the smallest number, the largest number, and the product of B and D according to the concept of averages. The middle number is the average number. So, the average of 4 consecutive odd numbers is 42, which means the middle number is 42. Since it is an even number, the 4 consecutive numbers are shared on both sides. Then, the consecutive numbers are as follows: 39, 41, 43, 45. Thus, the smallest number of 4 consecutive odd numbers is 39, the largest number is 45, and the product of B and D is 41 into 45, which is equal to 1845. It is noted that the average of any number series or group is always between its smallest and largest value. Let us look at another example in consecutive numbers. The average of 54 consecutive even numbers is 93. Find the smallest number and the largest number. It is easy to find the largest and smallest value for given consecutive numbers using the number of gaps among numbers. The first number in the set is the smallest number. The last number in the set is the largest number. The number of gaps is determined by subtracting 1 from the number of terms in the set. The total number of consecutive even numbers in this given problem is 54. The number of gaps will be 53. The smallest number will be 93 minus 53, which is 40, and the largest number will be 93 plus 53 equals 146. Let us now learn the second model for solving averages problems. Let's look at one example to understand the average concept in terms of with non-consecutive numbers concept. The average of 57, 49, 53, y, 62 is 56. Then find why there is a really interesting math trick behind it. To find the deviation of each value from the average value, you would subtract the average value from each individual value. For example, for the first value of 57, the deviation would be 57 minus 56 is equal to 1. For the second value of 49, the deviation would be 49 minus 56 equals minus 7. You would repeat this process for all the values given 53, y, 62. The sum of the deviations of a set of values is always 0. Then, the equation becomes y equals to 56 plus 3, which is 59. The third model for solving average problems is to use the basic average formula. The basic concept of finding the average of a set of numbers is to add all the observations together and divide by the total number of observations. The formula you provided expresses this concept mathematically. AVG is equal to the sum of all observations divided by the total number of observations. Let's look at an example to understand the basic concept of averages. The average age of A, B, and C is 26 years. If the average age of A and C is 29 years, what is the age of B in years? We can use the information provided to set up an equation to find the age of B, since the average age of A, B, and C is 26 years. We know that age of A plus age of B plus age of C divided by 3 is equal to 26. Also, the average age of A and C is 29 years. We know that age of A plus age of C divided by 2 is 29. We can use these two equations to find the age of B first. We'll substitute the second equation into the first equation for finding the age of B. Age of B equals 78 minus 58, which is 20. So, the age of B is 20 years. Here is an example to help you understand the basic concept of averages. The average age of 7 numbers is 5. If the average of the first 6 these is 4, what is the 7th number? We can use the information provided to set up an equation to find the 7th number. Since the average of 7 numbers is 5, now, we can find the sum of the 7 numbers is 7 into 5, which is equal to 35. Also, the average of the first 6 numbers is 4. We know that we can find the sum of the first 6 numbers is 6 into 4, which is equal to 24. Now we can subtract the sum of the first 6 numbers from the sum of all 7 numbers to find the 7th number. 35 minus 24 equals 11. So, the 7th number is 11. Let's look at the third example to understand the basic concept of averages. The average of 11 observations is 50. If the average of the first 5 observations is 47, and that of last 5 observations is 52, then find the 6th number. We can use the information provided to set up an equation to find the 6th number. We can find the sum of the 11 observations is 11 into 50, which is equal to 550. Now, we can find the sum of the first 5 observations is 5 into 47, which is equal to 235. Also, we can find the sum of the last 5 observations is 5 into 52, which is equal to 260. Finally, we can subtract the sum of the first and last 5 observations from the sum of all 7 numbers to find the 6th number. 550 minus 235 plus 260 equals 55. So, the 6th number is 55. Let's look at the fourth example to understand the basic concept of averages. The average age of 10 numbers is 7. What will be the new average if each of the numbers is multiplied by 8? If each of the numbers in the set of 10 is multiplied by 8, then the new average of the set will also be multiplied by 8. So, the new average will be 7 into 8 is equal to 56. Model 4, or the equation concept, is a way of solving average problems by setting up and solving equations. This method involves using the information given in the problem to set up equations and then using algebraic techniques to find the unknown values. Here is an example. The average salary of all the staff in an office of a corporate house is rupees 5,000. The average salary of the officers is rupees 14,000 and that of the rest is rupees 4,000. If the total number of staff is 500, the number of officers is. We can use the equation concept to solve this problem. Let x be the number of officers. Then, we know that the total number of officers is 500, and the number of non-officers, also known as the rest of the staff, is 500 minus x. We also know that the average salary of all the staff is rupees 5,000, the average salary of the officers is 14,000 rupees and that of the rest is rupees 4,000. We can use this information to set up equation 500 into 5,000 equal x into 14,000 plus 500 minus x into 4,000. We can now solve for x by simplifying the equations. So the number of officers is 50. We can solve this type of question in a smart way using the proportion technique. We also know that the average salary of all the staff is rupees 5,000, the average salary of the officers is rupees 14,000, and that of the rest is rupees 4,000. The difference between 5,000 and 4,000 is 1,000. Similarly, the difference between 14,000 and 5,000 is 9,000. It means that the ratio of the number of officers to the rest of the staff is 1 to 9. 1 plus 9 equals 10. Total value 10 is 500 staffs. Then, 1 value is 50. So, the number of officers is 50, and the number of the rest of the staff is 500 minus 50 equals 450. The fifth model of average calculation is a true or false concept. Let's look at an example in the average concept of true or false. The mean of marks scored by 100 students was found to be 40. Later on, it was discovered that a score of 53 was misread as 83. Find the correct mean. To find the correct mean, we need to adjust for the mistake in the score of 53 that was misread as 83. First, we'll find the total of all the scores before the correction. The total score is 40 into 100, which is 4,000. Next, we'll subtract the incorrect score of 83 from the total and add the correct score of 53 to 4,000 minus 83 plus 53 equals 3,970. Finally, we'll divide that number by the number of students to find the new mean. 3,970 divided by 100 becomes 39.7. So, the correct average is 39.7. In Model 6, the concept of including or excluding certain observations or data points is often used when calculating averages. Let's look at some examples of this average concept. The mean weight of a class of 35 students is 45 kg. If the weight of the teacher is included, the mean weight increases by 500 grams. Find the weight of the teacher. There is a really interesting math trick behind it. For including or excluding concepts, we use direct formula, that is, the average value plus or minus the change in value into new count is equal to the new person's value. Given that the mean weight of the class of 35 students is 45 kg, we know that if the weight of the teacher is included, the mean weight increases by 0.5 kg. Now, we can use this new mean to find the sum of weights including the teacher, that is 36. We can write 45 plus 0.5 into 36, so the weight of the teacher is 63 kg. Let's take another example to better comprehend this concept. The average weight of a group of 9 students is 43 kg. When a new student joins the group, the average weight of the group becomes 45 kg. What is the weight, in kilogram, of the new student? Simply, we can write 43 plus 2 into 10 is equal to 63. So, the weight of the new student is 63 kg. Let's look at the third example. The average mark of a group of 19 students is 76. When the mark of one student is excluded, then the average is decreased by 2. Calculate the mark of the student. Given that the average mark of the group of 19 students is 76, we know that if the mark of one student is excluded, the average is decreased by 2. Now, we can use this new average to find the mark of the student, which is 18. We can write 76 minus 2 into 18 is equal to 40. So, the mark of the student is 40. Fourth example. The average weight of M boys is 43 kilograms. If the weight of their teacher, who weighs 63 kilograms, is also included, then the average becomes 45 kilogram. Find the value of M. Given that the average weight of M boys is 43 kilogram, we know that if the weight of teacher is included, the average is increased by 2. Now, we can use this new count to find the value of M, which is M plus 1. We can write 43 plus 2 into M plus 1 is equal to 63. Solving this equation for finding M is 9. Let's look at the fifth example. The batting average of Sachin in 15 innings is 55. The difference between the runs of his best and worst innings is 65. Excluding the best and the worst innings, the average of 13 innings played by Sachin is 50. Calculate Sachin's best score. To calculate Sachin's best score, we can use the information given in the problem to set up and solve a system of equations. We'll call Sachin's best score B, and his worst score W. From the problem, we know the batting average of Sachin in 15 innings is 55. So, the total number of runs he scored in 15 innings is 15 into 55 equals 825. Excluding the best and the worst innings, the average of 13 innings played by Sachin is 50. So, the total number of runs he scored in those 13 innings is 13 into 50 equals 650. The difference between the runs, that is, 825 minus 650, becomes 175, which the best and the worst score of 2 innings. So, B plus W equals 175. From the problem, we know the difference between the runs of his best and worst innings is 65. So, B minus W equals 65. Solving these equations to find the best score. Simply add these equations together, we get 2b equals 240, then Sachin's best score is 120. Model 7. Replacement concept. The replacement concept in averages refers to the idea that when a player is replaced in a team, the statistics of the team should be recalculated as if the replacement player had been on the team the entire time. This concept is often used in baseball and cricket to better compare the performance of teams or players. Let's look at some examples to understand this concept. The average weight of 10 members in a family decreases by 2.5 kilograms when a new member comes in place of one of them weighing 70 kilograms. Find the weight of the new member. Simply, we can write 70 minus 2.5 into 10 is equal to 45. So, the weight of the new member is 45 kilograms. The average age of 8 men is increased by 2 years, when 2 of them whose ages 21 and 23 years replaced by 2 new men. The average age of the 2 new men is, simply, we can write, half of 44 plus 2 into 8 is equal to 30. So, the average age of the 2 new men is 30. The 8th model is average speed concept. The average speed concept refers to the measure of how fast an object or a person is moving over a certain distance or time period. It is calculated by dividing the total distance traveled by the total time taken to travel that distance. The unit of average speed is miles per hour or kilometers per hour. Let's look at an example in the average speed concept. A person covers 9 kilometers at a speed of 3 kilometers per hour, 25 kilometers at a speed of 5 kilometers per hour, 30 kilometers at a speed of 10 kilometers per hour. Find the average speed of the entire journey. To find the average speed of the entire journey, you need to know the total distance traveled and the total time it took to travel that distance. Distance traveled is equal to 9 kilometers plus 25 kilometers plus 30 kilometers is equal to 64 kilometers. To find the total time, you need to know the time taken for each segment of the journey and add them together. Time taken for first segment is equal to 9 kilometers per hour by 3 kilometers per hour is equal to 3 hours. Similarly, time taken for the second segment is 25 by 5 equals 5 hours. Time taken for the third segment is 30 by 10 equals 3 hours. Then the total time becomes 3 plus 5 plus 3 equals 11 hours. Now that you know the total distance traveled and the total time, you can calculate the average speed. Average speed is equal to 64 kilometers by 11 hours or 59 by 11 or approximately 5.82 kilometers per hour. Let's look at the second example. Speed Maths 4. Simplification Tricks. Solving questions from simplifications, a well-known rule, is called BODMAS rule. It gives the hierarchy of operations that stands for brackets, order, division, multiplication, addition, and subtraction. Let us now learn the different models for solving simplification problems quickly. The first model of simplification calculation is square root and cube root. Let's look at some examples to understand simplification in terms of square root and cube root concepts. Which is the greatest value among the numbers? The square root of 19 minus the square root of 17. The square root of 13 minus the square root of 11. The square root of 7 minus the square root of 5. The square root of 5 minus the square root of 3. Let us consider the first number, the square root of 19 minus the square root of 17. You can rationalize the square root of 19 minus the square root of 17 by multiplying the numerator and denominator with the square root of 19 plus the square root of 17. Multiplication can be transformed into a difference of squares using the rule a minus b into a plus b, which is a square minus the b square. Here, a square value is a square root of 19 squared, which is 19. B square is the square root of 17 squared, which is 17. The difference between 19 and 17 is 2. Then the result becomes 2 divided by the square root of 19 plus the square root of 17. Similarly, we can deduce the other numbers. The result of the second number is 2 divided by the square root of 13 plus the square root of 11. The third number is 2 divided by the square root of 7 plus the square root of 5. The fourth number is 2 divided by the square root of 5 plus the square root of 3. Here, you notice that the lesser value in the denominator gives the greater number. So the answer is the square root of 5 minus the square root of 3. Let's take another example to better comprehend this concept. Which is the smallest value among the numbers? 2 power 250, 3 power 150, 5 power 100, 4 power 200. When the power of given numbers is divided by 50, the numbers become 2 power 5, 3 power 3, 5 power 2, 4 power 4, and the results are 32, 27, 25, and 256 respectively. Therefore, the smallest value among these numbers is 25, which corresponds to 5 power 100. Let us now look at some additional examples. Find the square root of the square root of 915,849 plus the square root of 795,664. As was covered in the Speed Maths 2 video, it is simple and smart to find the square root of a given number. The square root of 915,849 is 957, and the square root of 795,664 is 892. The sum of these two square roots is 957 plus 892, which is equal to 1849. Finally, the required result can be obtained by taking the square root of 1849, which is 43. Next, consider the nested radical function. How to simplify the square root of 12, under 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 square root of 12. There is a really interesting math trick behind it. We know that The exponent form of the square root of x is x power 1 by 2. Here, denominator 2 denotes the square root. Numerator 1 represents the denominator value minus 1. It is noted from the question that there are 6 square roots. Hence, the denominator value would be 2 power 6, which is 64, and the numerator value would be 64 minus 1, which is 63. Therefore, the numerator and denominator values would be 63 by 64. The solution for this question would be the simplified form of 12 power 63 by 64. Let us consider another expression, where infinitely many radical expressions are nested within each other. Simplify the square root of 9, under the square root of 9, under the square root of 9 continues up to infinite. There is a really interesting math trick behind it. The square root of x, under the square root of x, under the square root of x, and continues until infinity should be x. Using this concept, we obtain the required answer. Always remember that the solution is the specified number itself, which is 9. Let us consider another example in the nested radical function. How to simplify the square root of 4600 plus under the square root of 540 plus under the square root of 1280 plus under the square root of 250 plus under the square root of 36. The solution to the square root of 36 is 6. Then it is added to 250, and the value becomes 256. The square root of 256 is 16. Then it is added to 1280, and the value becomes 1296. The square root of 1296 is 36. Then it is added to 540, and the value becomes 576. The square root of 576 is 24. Then it is added to 4600, and the value becomes 4624. The square root of 4624 is 68. Let us look at a final example in the nested radical function. How to simplify the square root of 72, plus under the square root of 72, plus under the square root of 72, plus under the square root of 72, plus continues up to infinite. In math, 72 can be written as 8 multiplied by 9, or 8 times 9. The smallest value is 8, the highest value is 9, and the difference between these two values is 1. There is a really interesting math trick behind it. If the nested radical function has a positive sign, then the solution is the product of the highest value and the difference between two numbers. Likewise, if the nested radical function has a negative sign, then the solution is the product of the lowest value and the difference between two values. In this problem, the nested radical function has a positive sign. So, 9 into 1 equals 9, which is the final answer. The second model of simplification calculation is percentage concepts. Let's look at an example in the percentage concept. 35% of 580 minus 70% of the question mark is equal to 441. What value should come in place of the question mark? First, 35% of 580 can be calculated as 203. When we subtract 203 from 441, we get 238. So, 70% of what value is 238? We know that 238 divided by 7 equals 34. Hence, the answer is 340. Let's look at the second example to understand this simplification concept by ignoring percentages and 2 zeros. Simplify the equation 20% of 160 plus 30%